Yeah.
Okay, good afternoon everyone. Welcome once again for another webinar series. Ito po ay continuation for our smart cities, and we are now on the series number 3, which is the role of automation in our community. So before we start, let's have a prayer. We have here Pastor Sunny Medina. Pastor Sunny, good afternoon, Pastor Sunny.
So we are going to start with some examples in here. Regarding this box, an example which says
Pastor Sunny,
here. So we are going to start with the right side.
yeah. Nakamute ka, nakamute.
Sorry. Oh, powerful afternoon, everyone. So thank you, Chairman, and to all, Ma'am Mylene and Jenny Lou and our guests for this afternoon. Thank you very much once again for having me. It's July 18, 2020. And again, we have a very, very interesting topic, the role of automation in transforming our community. And today, what I will share to all of you is very relevant. The role of God in transforming our lives. In John chapter 3, verse 16 says, For God so loved the world that he gave his only Son, that whosoever believeth in him should not perish, but have eternal life. So God's role in the life of people, number one, he loves. God loves unconditionally, and that's true. When God loves us, he gave his only Son, and selflessly, he gave it all. And whoever, nobody can give their own son as a sacrifice to those they don't know. But God Himself gave His only Son, and that's His role. And secondly, is He gave, He loves, and last is He saved. When God saves, unselfishly. When He loves, unconditionally. When He gave, eternally. And in Romans chapter 12, verse 2 says, this word transforming, which is God's role to every one of us, it says in Romans chapter 12, verse 2, be ye transformed by the renewing of our mind. Yes, God wants us to transform. He wants us, God is in the business of transforming from nothing into something, from sinful life into God's nature life. He wants us to have life to the fullest. Yes, friends and brothers and sisters, God is in the business of transforming our lives from sinful life to godly life. Good afternoon, everyone. That's the role of God in transforming our lives. So let's pray, everyone. Father in heaven, thank you, Lord, for this afternoon once again, oh Lord. You have given us the opportunity, oh God, to learn more, oh Lord, of this topic, the role of automation in transforming our community. Lord, you are the one who gave us time, and may we use this time, oh Lord, with quality, oh God. Help us, oh Lord, and be with us from start to finish, and bless everyone this afternoon. To you all the glory, honor, and praise. In Jesus' name, amen and amen. Thank you very much.
Salamat, Pastor Sunny. Of
God bless
course,
you.
we also have Ma'am Mylene Abiba from Felca Multimedia and Jenny Lu as our moderators for today. So we prepare something for you. So we also have a guest speaker from USA, from Gearbox Labs. Good afternoon, Ma'am Jen. Good afternoon, Ma'am Mylene.
Good
Kamusta?
afternoon, Ma'am Jen. Good
Hello.
afternoon, Maylene.
Yes, good afternoon to all our viewers. I just wanted to today is a special day because for the first time in several months we are broadcasting in the afternoon. Usually it's in the morning. So this is just an unusual day because of the power outage in Olongapo where our beloved chairman Wax is residing. So it's just by next week we go back to the 9 to 12 schedule every Saturday. And I am honored to introduce to you our partners of the Felta Multimedia. We're so grateful that they have woken up very early in the morning to join us this this afternoon in the Philippines. And Peter Haydock has 25 years experience as an educator. And Isabel Mendiola, Peter Haydock is the Chief Executive Officer and the Chief Operations Officer of Gearbox Labs from Wisconsin, USA. And Isabel Mendiola is the president. She's also an educator with 17 years of experience as an educator. And they will be presenting to us the Gearbox Lab demonstrations and also the Arduino classroom demonstrations for us to use the Arduino in our respective schools or our respective homes. So I give to you Peter Haydock and Isabel Mendiola. All the way from Wisconsin, USA. A virtual applause since they have woken up so early in the morning. It's 3 o'clock in the morning in USA. And I hope they have their coffee.
Sarado ata yung mic.
Right. So we have...
Yeah. They were having internet technicalities earlier. So,
it's not just the Philippines, even in the USA.
yeah. Oo,
In the
grabe. I think it's because a lot of people are using the service. So, yung na-maximize yung bandwidth, no? So, yung distribution is very crucial talaga. Even here, I was lucky to get the last slot doon sa box. Kasi it's gonna take months before they line up a new one.
I think we
so
should, yes.
yeah, while waiting, once they get back.
But they have, they were smart enough to do a pre-produced
Correct.
video.
Naramdaman na nila to eh.
Na-anticipate nila na magkakaroon ng internet problem sa Wisconsin. So let's have the video of the actual demonstration, and they will be with us for the question and answer.
Okay.
Yes.
So we started this curriculum in our science lab and was for supporting our subjects physics, chemistry, and biology. So today we are going to give you a tour about every sensor and how we are using it. So we are going to start with in some examples in here. Um, we have in this box an example of each sensor, which is placed in here. So we're going to start with the right side of the box. We have one of the sensors, which is the sound. We use this one for building prototypes that identify sounds in barns or fields, and they as well as an alarm. So let's take a look at the sound sensor from our curriculum. Our next sensor is the soil moisture. So we have the sensor and with a cable. This sensor goes into the soil like this. We will have an example. Sometimes we attach an LCD so the information can be displayed. Let's take a look at the soil moisture video from the curriculum. Our next sensor is the resistor. We use this one for detecting intensity of light. And by adding a switch, we can turn off or on lights. Now let's take a look at the light sensor from our curriculum. Our next sensor is a tilt. This tilt sensor, we use it for controlling the angle of inclination of tractors or sprayers in agriculture. Let's check the video showing tilt sensor at work. So let's take a look to the following sensor, which is the distance. This one measures distances between a sensor and another object. It's useful as well for surveys. The distance sensor video shows how it measures distance to a moving object. The following sensor is part of the family of the MQs, and these sensors can detect uh, gases such as CO2, O2, and alcohol. But in this case, we are using this one for detecting methane. It's an MQ4. We use it in farms, barns, for detecting levels of methane. Thank you for measuring volatile organic compounds as shown in the following video. Another sensor that you will find in this box is the color sensor. Very useful in industry. This one will measure the maturity of fruits, intensity of color in leaves, as well in poultry industry for measuring the quality of eggs. The color sensor measures red, green, and blue reflected light from objects as shown in the video. Another sensor that we will find in our box is the humidity sensor. This one measures the quantity of water. We use it in agriculture for testing quality in ponds, lakes, or for the water that animals are drinking. Here we show the turbidity sensor monitoring the quality of water. So another sensor that we will find in our box is the infrared sensor. This one detects absolute temperatures in crops to see that the quality of the plant. As well as some excellent obstacle avoidance for a tractor. So let's take a look to the next sensor, which is the heartbeat sensor. This one is used in agriculture for checking the heartbeat in cattle. The heartbeat sensor as shown in the video measures the systolic and diastolic beats of the heartbeat. So our last sensor is a pH. This is an example of a pH sensor. We use it in agriculture measuring availability of water and soil. By placing the blower inside the water or soil, we can detect levels of pH and information is going to be displayed in the Excel. The pH sensor is my favorite. We replace newspaper in my chemistry labs. So these are the sensors that we will find in our book. So we are sharing the application of these sensors in agriculture. There are many other sensors that can be put up into the Arduino controller that can be used in agriculture.
Okay, so that is the demonstration of from Gearbox. Seems
Yes.
no, they
Oh,
are back again. Sige, ma'am,
yes.
may introduce again
Yes.
speaker.
I just want to inform our viewers that Peter Haydock and Isabel Mendiola are both authors of the Arduino Classroom. So all the experiments that you have seen, the projects you have seen, they have done it on their own. So they are the authors of the Arduino Classroom, and we know that it's so difficult. If not, I have not even seen a curriculum. So we have done a curriculum for Arduino Classroom, and they are the authors of that. And they're also from Wisconsin, USA. So it's very early in the morning there, and they're trying to come in into the studio. We hope that they'll be successful. If in case that their internet is still very weak at this point, we'll proceed with Jen and Dominic for the Tinkercad, and we will call them again for question and answers in about an hour. I think their internet is not very stable at the moment.
We're having
So
problem internet
yes,
connection.
let's proceed. Yes, so Peter Haydock and Isabel Mendiola will be joining us in about an hour after the Tinkercad presentation of Jen and Dominic. So take it away.
Okay, so for all of our participants for today's webinar, now we ask you to have your questions. If you have question, you can just put that in the comment box here at FB page and also with the YouTube channel. Okay, so we can show to our resource speaker the question so that they may answer. Okay, Ma'am Jen. So let us introduce Ma'am Jen, our speaker. Ma'am Jen.
Hello, ayan. We were going to remind first those who are watching us live in Facebook, you can allow StreamYard so your name will be displayed in our comment box, and so therefore we can address you directly. Ano kasi ang lumalabas po sa amin ay Facebook user. All right. So today is another episode we have two consecutive episodes on automation. So now we are going to focus on smart cities. What are the components of the smart cities? Yung mga pinakita po sa inyo is more on what Arduino parts are we using dun sa ating classroom. And then Dominic will share you his setup, and we'll also discuss with you on how to teach it. If you don't have the kits yet, he will be discussing using Tinkercad and another site. Okay. So before we proceed with Sir Dominic Sales, let me share with you my screen. Sir Wax.
Okay,
Share.
where's your screen?
Ay, sorry, wait lang. Ayan. Okay. Yeah. Okay, I'm gonna show you a short video first. What is the automation and what is its role in the smart cities of the future? Okay, Sir Wax. My full full screen. Hindi ko na kayo nakikita. Pwede ba ako pala? Half pala, Sir Wax. Para kita ko. Saan na ba ako? My screen and myself. Sorry. Okay, so meron tayo kanina. Liitan natin to para nakikita natin. Kanina nag-demonstrate si Miss Isabel ng ating mga smart cities, no? So, ang topic for today is series 3, the role of automation in transforming our community. So, when you have samples at home, hindi naman kailangan na super mamahalin, no? So, I have here a sample na madali niyong mapapurchase na parang sa mga batang maliliit. Like automated solar motion sensor light. So, ito yung sample. So, pag tinakpan ko, yan, medyo nakakasilaw. So, you can introduce, so yung sa sustainability natin sa unang-unang part sa Series 1, ito yung mga sample gadgets na madali yung mapapakita. And we can always make use of these para ma-catch yung attention. So we get the attention of the students and make them more interested in the topic. So this is one, and we have a lot of samples we can choose from na we can already get locally, ano. So dito sa ating presentation, Sir Wax, I have my PowerPoint in full na. Okay, so smart cities, the role of automation in transforming our community. In the video we saw earlier, There are prerequisites. Smart cities will not work without IoTs and without automation. They come hand in hand. So, as engineering careers, automation and robotics engineering are involving several areas. So we have electricians and mechanics that combine together. That's why the course mechatronics came about. It's a combination of electrical, mechanical, software, hardware, and infrastructure. So each of them play a major role in this complex area of the engineering process. The role of the roboticists and the automation engineers is to design, build, and maintain the machines. Maraming entry point. It's open to any kind of character. So from starting tech book graduates to PhD graduates, there are jobs waiting for them. Robots have four elements. We have the mechanical part, the electrical part, hardware infrastructure, and software. In this webinar, we will have the hardware and software samples. Earlier, we had gearbox, so demonstrated us how to use the gearbox kit, the Arduino curriculum, in integrating it in the classroom. Later, Sir Dominic will show us the online, the Tinkercad version, and another software he will introduce later. This the benefit of having this kind of discussion in the classroom and a class in a subject in the classroom is automation and robotics is within the emergency services na ngayon. It also involves military and medical operations, not just being part of the smart cities, but a major component in transforming our community. So some people are confused. Is automation IoT or Internet of Things? Or is IoT the automation? So automation is just a tiny part of IoT. It doesn't mean that you have automation, it's always the IoT. You have automation as part of the IoT, and most likely the parang byproduct na nga lang siya. So we have different types of automation. One common is the home automation, and some of those we can remotely control as we can use our mobile devices. We also have um, industry partners that uses automation to speed up the processes. What are the benefits of IoT and automation combined? Some people are confused that these automations and IoTs are removing jobs or like lessening jobs for human. It actually is generating a different type of job. It's not actually wiping down the human resources. Now we do need humans to operate on the machines and set things up. So it involves reducing cost. You can even do it work from home. It improves quality, it increases production, it's improving satisfaction, and of course, we reduce carbon footprints. There are crucial elements in the smart city development. First is the smart industry, then we have smart technology, smart management, and smart services. Okay, so the sensors, which were shown earlier, are taking a major responsibility in making the connection possible for specific communication and information exchange. So in the automation, you will see how these sensors help in gathering data, which is really important, as the data is used for to trigger or as conditions to make sure that the automation will work as expected and as programmed. Okay, this helps to locate, monitor, and track and manage and enable smart recognition on everything. So sa mga houses, there are a lot. If you look at the picture, there are outdoor flash sirens. We have PIR detectors, and we have magnetic door sensors, and a lot more. What are important is security, not just in security in terms of are people going in your house unallowed. It's also on what if you leave your houses and you are traveling, you don't know how safe it is anymore because of the change in weather. There might be changes in the total condition of the houses. So we have triggers that will allow us to make sure that the house is safe, whether there are people in it or not. Okay. In the streets, we have smart infrastructure. So our city has to have smart infrastructures as we go with the trend. We have smart lighting. Smart lighting helps authorities keep track of the use of light in real time. So most of the streets now have their solar powered street lights, but some has more complicated lighting facilities. So this is one example where it is a cloud-based control system where authorities will just turn on or off specific lights. Okay, there are some that are more uh, advanced as it optimizes illumination. For example, if you look at the picture, the lights will be brighter when it's closer to the moving object as it's saving energy on the ends, like the first picture above you have 20% as it's farther from the car. It's 100% as the car is right across or adjacent to the street light, and it's darker when it's not yet coming towards the end of the other light. Okay, for the picture at the bottom, you're seeing since there's a person in the lower left hand corner, it's 80% because I think the idea is the person is smaller than the car, therefore it doesn't need that bright light as it only occupies a smaller space. And of course, it's darker as it's not reaching the third, fourth, and fifth lights yet. So darker and darker when it's far, brighter when it's closer to the lights. Okay. The next part of so that is the smart lighting. The next part is connected smart streets. So if you look at the photos, the devices are fetching data about roadworks, traffic, and blockage. So merong mga vehicle sensors, and it's triggered by the cloud-based infrastructure also. May GPS, and it's locating where the vehicle is at, and it's telling you somebody pressed on the the pedestrian button that says somebody will be crossing, so the lights will be triggered, something like that. So it's managing people and resources and making public transport more efficient. Okay. There also are smart parking management. So smart parking management helps find vacant spots for parking a vehicle at various public places. So if you're going to look at the photo again, you're seeing that it's telling you, it's giving information on which one is vacant and which one is not. So on the photo, it's on the street itself, on the side. Okay. This system is based on in-ground vehicle detection sensors. So wireless sensors transmit information regarding the time and duration for which a parking spot is used. Okay. So no congestion here because the people will know if there is free parking or not. And if you are trying to find a spot to park, it's going to give you information. Okay, these references I found here. So, ano ba ko yan? If you have questions, you can ask us on the chat. I don't see you yet. I'll look at the chat, the comment box later, and I will try to answer your questions. Okay. So for Sir Dominic, he will be introducing us how to teach it in the classroom, and he will give you a demo. Okay, Sir Wax, let's see. Sir Dom. Ayan. Hi, Sir Dom. Good
Hello,
afternoon.
hello. Good afternoon, Ma'am Jen, and good afternoon to everyone watching here right now.
Mhm. Yan. Palapit konti yung ano, cam. Medyo maliit, no? Okay.
Okay, so today Sir Dominic Sales will demo us, no? He will be demonstrating the Arduino, how to use the Arduino. Tama ba?
Yes.
Yes, sir. Yes, sir.
Okay.
That's correct.
So
So we'll
let's
be using for the first part of the demonstration, we'll be using Tinkercad, and then at the end of the demonstration, right after using Tinkercad, I'll be demonstrating on how to use the actual Arduino kit, which is I'm going to use Arduino Mega and some LED here, soil moisture and water sensor to demonstrate how these things works in an actual Arduino kit. Okay, so Ma'am Jen, are you still there?
Yes.
Okay, may question po tayo dito kanina, no? Sabi po ni Ma'am Bilen, may I ask if I need to open Tinkercad to go along with the lecture?
Oo nga. We suggest you open it na because it's not some internet connections are slow. Maybe when you try as it's ready na, so you can try to access is it there. So for those who are new, Sir Wax, I will send you the link, so they will just click in the comment box. No, tama ba?
Sige.
Sige,
Okay,
wait
so
lang.
Sir Tom,
Hello, Ma'am Jen. Shall we start the demonstration?
Sorry.
yes po.
All right. So once again, good afternoon, everyone, to all the viewers out there in YouTube and in here in Facebook. Um, I am Dominic Sales, and I'll be demonstrating on how to use Tinkercad as an online simulation tool to create basic Arduino programs and design basic circuits using Arduino programs. Okay, so for you to be able to follow the demonstration, I want you to log to open your browser in your computer. If you have your tablet or your computer with you right now, kindly open www.tinkercad.com. As you can see in my screen, I think I'll be sharing my screen right now. Yep. So can you see my screen, Ma'am Jen? Just a confirmation.
Yes.
Yes, I see it.
Okay,
Okay.
cool.
And then
Now,
and
so
then yung link nasa ano na din, comment.
yes, yes, yes. So
Okay.
this is Tinkercad, wherein it offers a lot of really good stuffs, features. So you can create 3D designs, you can create circuits, code blocks, and of course we have also the lesson here. So which means to say it's like a Google Classroom. But for today's session, I'll be focusing on the use of circuits. So make sure to create your free personal account here in Tinkercad. For you to be able to do that, of course, you need to have your working email, okay? And then create or create a personal account here in Tinkercad. So I'll be demonstrating now how are we going to use Tinkercad as a replacement of an actual Arduino kit. For example, we don't have the actual Arduino kit, then we can still do coding and robotics. Still, we can program, design circuits using, of course, this amazing Tinkercad here. Okay, so if you have your account ready, so maybe we can start with the demonstration now. make sure that we have the same screen as you can see now. So make sure to click circuits, okay, here. And of course, we need to create a new circuit, okay. If you're new to Tinkercad, and if you want to make sure that you have the same screen, you simply click the logo here, the Tinkercad here, the logo in my upper left corner, you can see. So just simply click that icon or the logo there, and then you'll be able to see this friendly dashboard in my screen. Okay, so that we have the same screen later on. Okay, so simply click this or select this, and then select circuits, and then let's create a new circuit. Okay, so press create new circuit. Okay, for the first part of this demonstration, I'll be discussing with you the environment of Tinkercad, of course, and also after that, just a quick review on the structure of an Arduino program. Okay, so ano nga ba yung meron sa isang Arduino program? I think it's very important for us to know the basic structure of an Arduino program. Okay, and after that, I'm going to teach you how to use the serial monitor, and of course, we will use the LED, the resistors, and other sensors. Okay, and after sensor, I'll be demonstrating how to create or how to use the servo and potentiometer. Right after the servo, I'll be using the distance sensor or the ultrasonic distance sensor. And at the end of the demonstration, I'll be demonstrating how to create circuits using the actual Arduino kit. Okay, so I hope you have your Tinkercad open now, so that we have the same screen. So this is the environment of Tinkercad. As you can see here, it's very easy. You can see just here in my screen, right corner of my screen, you can see the different components available. So these are all the basic components available in Tinkercad. Take note, these are just the basic components, okay? Which means to say that Tinkercad offers a lot of components here. You simply select the basic here, and you can see the components here. Okay, so all components. Okay, if you want to see all the different available components here, right there. So these are the different available components. Okay, so it's up to you to navigate all of these components later on. We'll just go back to basic. Okay, so on my right part of my screen, these are the components, and you can see here, for you to be able to create a code or add a code in your circuit, make sure to click the code here. Okay, for the meantime, we can see the editor because we don't have a circuit or we don't have a design yet. Okay, so yeah, so simply press code here if you want to create the program. And of course, if you want to simulate or if you want to see the actual output of your circuit, or if you want to run your program and see the output, then you simply press here the start simulation, of course. Okay. And then, of course, if you want to edit, go back to your circuit design or go back to your code, you simply click again the start simulation or the stop simulation here. Okay. Here you can see the fabulous denser Fofi. This is actually the file name. It's quite weird, but you can actually change the file name here. You simply double click, and then you can type your desired file name. For example, this is Falta das Arduino demo. You can rename whatever name you wanted. Okay, so Falta das Arduino demo, and then simply click anywhere in your screen to activate the new file name of your Arduino program. Okay, and of course, here we have the rotate. If you want to rotate your components later on, your sensors and your board, simply select the component, and then of course, click this icon for you to be able to rotate or change the orientation of your component. And here we have also the delete icon, wherein if you have components, unnecessary components, accidentally added unnecessary components, then of course you need to select the component and then simply press delete in your keyboard or click this icon here. Okay. Also, we have the redo and undo. Okay. And we have also here the annotation and of course the view and hide. Okay. Here we have also the export. If you're done with your program, of course, you can actually export your circuit design. And at the same time, you can export the program. Okay. You can also share your circuit or your your document. Okay, so just you simply type the name of your or the email of your the one that you want to share with your to share your document. Then you simply type the email address. Okay, and I think so much with the environment of Tinkercad. Right now, I'm just waiting for Ma'am Jen if I'm continue with the demonstration, or we have some questions. Ma'am Jen, do we have some questions with the environment of Tinkercad, or we proceed
Yeah.
with the demonstration?
So we have talagang interactive learning today, and we can check if we're too fast or too slow or just fine. I invite everyone to go to, if you have the app, or you can click to another, you can split your screen for the browser para lang we can check if you can follow. Please, Sir Wax placed in the Socrative student login. You don't need to sign up or anything. Just go to the virtual classroom. Name is virtual math. Okay? Virtual math. So we will be asking, kasi you cannot respond right away as we are live now, no? So I will be asking, and then you will just say, good, 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 or something, and then we'll know if you're ready or not. If I reach at least 50%, doon or 70% of the participants, we can proceed with the next one, another DOM, so we can check. So
Yes, ma'am.
while waiting for you to get started, I know some of your internet connections are not that fast. We will wait for you. And yeah, how many simulations are we going to need, Sir Dom? Do we just use one file, or patong-patong ba yon? Or do we add on, or we use the same board?
I'm going to use the same board, but
Uh-huh.
I strongly recommend for our viewers to create a new document or new file for them to be able to have a copy of their previous file.
Yan. So, we do encourage you to do that. So, for example, what's the first sensor we're using, sir?
The first part of the demonstration would be it will focus on the serial monitor followed by the LED, and of course we have here the sample sensor here, the ultrasonic distance sensor. Ma'am.
Okay. So, we recommend that you use, ano ba? You have the file name to be the sensor, so you know which file. Kasi you can always create a new file, and it's easy to grab the board and the breadboard, right? The ID and the breadboard. Okay. So wait lang. I'm signing in. I can't even sign in on my own. Okay, so I can check if you are ready.
Okay, Ma'am Jen, Sir Dom, I already posted the activity for today. So sa mga participants po natin, you may go to YouTube channel and proceed to the login sa https://b.socrative.com. Login student, then
Mm.
click on what? The
Yeah,
room name.
I have two students there already. I think there are how many viewers na? Yan. But if you're using your ano lang, your phone, it's fine po. Don't stress. Okay, so just for those who can, so we can and wants to let us know if you're ready or not. Kindly go to socrative.com student login, and then the classroom name is virtual math, no space, all caps. Did you post it in the comment box? So,
Yes,
ayan.
already.
So, I will try to put a question. My question is, are you ready? And let's see if people will respond. I have two students. I only have two students. I am not sure if I will see some answers. Okay, I have. Yes, okay, I got one. Okay, I have one student who said yes. Ayan. So this is how we know that you're out of my two students who were able to successfully go in the virtual classroom. Uh, yes, ma'am. Okay, I got 2 out of 2. So I have 2 students, those who were not able to follow. Sir Wax, can you pin the link and the classroom name doon sa ating banner?
Naka-plus
Ayan na
already.
pala.
Oh.
Okay, can you add the classroom name is virtual math? Okay, we'll wait for you. I think you can start na, Sir Dom. Baka maiwan tayo. I will keep it open.
Okay, cool.
Thank you.
So thank you, sir. Thank you, Ma'am Jen, and thank you, Sir Wax. So again, guys, let's continue with our demonstration on how can we use Tinkercad. Okay. So first, let's try to add an Arduino Uno R3 board in our we're playing here. Simply select the Arduino Uno board here and drop this microcontroller in our Tinkercad space here. So as you can see in my screen, the Arduino Uno board is quite complicated. But if you have a background using this Arduino Uno, a basic background, then it will be a plus on your part. So just a quick review on the parts of the Arduino Uno. You can see here the different digital pins here on the upper part of the Arduino board. You can see the digital pins. Okay, we have the GND, which means that's the negative pin. We have also the 1312 up to 0. These are all the digital pins we have. Also, we have here the red button here. This one is the reset button. Okay, so once you press this button here, that means to say that all the program inside your Arduino board will go back to 0 and it will be no reset. Okay, but the program, don't worry, the program will not be deleted. Also, we have here on the lower part of our screen, we have the different pins, the digital in the upper here, upper or lower corner of our screen, we have the analog pins. We have A0 to analog 5. We have also the VIN, the GND, the 5V, and the 3.3, and the reset, and then the IO ref. Also, we have here the USB port, and also we have the jack here to power our Arduino. Okay, so going back to our demonstration, the first part of this is let's try to create a basic circuit using an LED. Okay, let's try to power up an LED using this small board here. So first, we need to add a breadboard in our editor here. So simply select the breadboard and then drop the breadboard in your editor. Okay, so we have the breadboard right now. As you can see in my screen, if I'm going to mouse over or to select pins here, you can see that there is a small green circles here connected to each other. That means to say that this is actually a group and they are connected to each other. Okay. The same with this power bus here. You can see if I'm going to select one pin here, then everything will be selected. That means to say it's a group. Okay. So yeah. And of course, let's try to add a resistor here. Okay. So resistor is simply the functionality of resistor is to simply control the flow of the electricity or the voltage. Okay, so let's try to add this resistor and let's connect this resistor in our breadboard. Considering the pin, we have here the D5 and we have also the F5 here. Make sure it's in on D5 and F5 for the meantime. But I'm going to discuss, of course, the importance of having a clean circuit design in Tinkercad. Okay, and of course we have the LED. We need to add an LED. Okay, so simply look for the LED here and then drop the LED here. Okay, and let's zoom in. Okay, so we have two legs. You can see the cathode and the anode. Okay, if we say cathode, this means to say that cathode is simply the negative pin or the negative leg from your LED. And of course, the anode is actually the positive leg from your LED. Okay, so let's select this LED and rotate. Okay, let's rotate this. Okay, on my upper left corner of my screen, you simply click this icon here. Make sure that your LED is selected and let's rotate this LED here until such time that the orientation is something like this. Okay, and then move your LED. Okay, making sure that our cathode is connected to our negative pin or negative hole here in our breadboard like this. So you can see in my screen, this is the cathode is connected to the fifth pin of our from our breadboard. Okay, and also we have the anode with which is the positive. Make sure to connect that in our breadboard here. In it's up to you if you want to connect this to A5 or B5 or C5, as long as they are aligned together. Which means to say, since we connected our resistor a while ago in D5, then our LED should also be connected under this column. Okay, which means to say it should be on the column of number 5. So let's try to use A5 for the meantime. Okay. All right. So we have successfully connected the positive leg from our LED going to our A5 from our breadboard. The next thing to do is to make sure that we power up our breadboard by simply adding an extra wire here on the first hole from our breadboard. You simply click this. Okay, you can see the wire. This is the wire. Okay, and then connect this wire in our GND. So GND means negative. Okay, we can also change the color of our wire. You simply select the wire, and then you can see here the color. We can change it to black. Okay. It's always proper to change the color of our wires. So proper wiring code is really important. Okay. So black since it's negative. Okay. And we need to connect our resistor or our LED to the digital pins from our Arduino. So let's try to use 13 for the meantime. Okay, and let's connect this wire here in our J5. Now, going back, make sure that everything is okay. You can see in my screen, it's in the same line or it's in the same column. As you can see, we use 5 here, A5, D5, F5, and also here we have the J5. So everything should be aligned together. Okay. Once done, we can actually proceed with the program. Okay. So just simply click the code here. Okay. So select the code, and then you can see here we have here the blocks, but we're not going to use blocks. Select the blocks, and then there's a drop down list. Just simply select text. Okay. So select text and then press continue. Okay. Select text and then continue. All right. So maybe I'll pause for 5 seconds. Let's wait for the viewers. Okay.
Ay,
So I hope
sorry, I was muted. Hold on, Sir Dom. So, and I already have 6 students in the classroom. So, Miss Lori Bell said no. I asked them, "Are you done wiring? Any questions?" So, Miss Lori Bell said no because I can't access the link. So, if you are talking about the Tinkercad link, Sir Wax, can we repost the Tinkercad link po? Maybe because okay, so MB got it. So we have 1 out of 7. I already have 7 students. One is done. Yes. So I have 2 yeses and one. Okay, Sir Wax said yes, but I'm telling you to do it first. Put the link, Sir Wax, before you do the activity. You are the moderator. Okay. Sir Wax, repost Tinkercad link po, please. Sa comment box, so they will just click on it. Ayan, yeah, okay. Sir Wax already posted the link. You just have to click it. And then, thank you to the 7 people who are trying to talk to me. Okay, Atomo said yes. Okay, done wiring. I'm waiting for 2 more students. 3 more. Okay. Very good. I love that I can. Okay, Donnie says yes. Okay, one more student left. Sir Dom, it looks like this is how we're going to teach in the beginning of the school year, no?
Yes, ma'am.
Okay. I think we can proceed with, we're on the coding na, right? So,
Okay. All right.
Miss Loribel, madali lang po yan. We'll wait for you can comment if you are still having difficulties in our YouTube live. Thank you. Bye, Sir Dom. Go ahead na.
Okay. Thank you, Ma'am Jen, and thank you, Sir Wax. Going back to our demonstration, guys, you can see now that there is an actual code provided. Well, actually, we did do this, but this is the default program given to us by the Tinkercad so that we can start doing the programming part. Okay. So you can see under here, we have the void setup and void loop. Okay. When we say void setup, this means to say that this is the actual, the first part wherein um, we declare everything like the pin assignment, the variables, initialization, or whatever components we used. Okay, we have used. No, so under void loop, this means to say that our program, whatever the program is, when it's inside our void loop, then it will run repeatedly, continuously, as long as our Arduino or our microcontroller board is on or power on. Okay, so these are the two important parts of an Arduino program. We have the void setup and void loop. Now here we can see that there is an actual program which is pin mode 13 comma output. This is given to us by the Tinkercad. So we didn't do this again. It's pin mode 13. Pin mode means it's the pin assignment, okay, that we use. You can see here there is a 13 here, which means to say this is the digital pin we used a while ago, okay? And output means because we used an LED, then it should be output because an LED, nag-emit ng light yung LED natin. So nag-on, nag-off, then it should be output. Okay? So kung ang component natin, if our component is actually accepting values, then it should be an input. Pero kapag nagpro-provide ng output or numbers, then it should be a digital component. Okay? So yun pong panagkaiba ng output and input. Okay? Then also do not forget the semicolon here, which means to say this line is a single statement. Okay? Under void loop, we have here the digital write 13 high, delay 1000, which means you can see here this is a comment, it's a guide, which means to say the first two lines, it will turn on our LED. Okay? So kung ano man yung nakalagay sa pin 13 natin, then automatic na i-on niya. So nasaan yung on? Here, we have the high. Okay, we have the high here. It's digital right because we use the digital pin 13. You can see in our design, we have used the digital pin 13 here. Okay, so you can see the label here. It's digital. Okay, that's why it's digital right 13 high. Okay, and the last two lines here, we can see that it's digital right 13 low, which means to say turn off our LED for 1 second. So the output of this program will actually is actually the LED will turn on and turn off, turn on and turn off for every single second. Okay, so let's try to simulate the program by simply pressing this start simulation here so that we can see the final output. Okay, now you can see that my LED is actually turning on and turn off. It will turn on and turn off at the same time. The reason behind this is we have the correct program and we have the correct circuit design. Everything is connected, and in our program, everything is written. Okay, we have pin 13, we have digital write high and digital write 13 low. Now, in case we want to edit or we want to transfer the pin assignment of our LED and we wanted to use digital pin 8, okay, let's say digital pin 8, then we simply stop simulation. Okay, again, we simply press stop simulation for us to be able to edit our program. Okay, and then let's go back to our circuit. I'm just going to zoom in. And in case we want to change pin 13 here, we simply delete this wire. Okay, select the wire and then press delete in your keyboard or simply press this icon here. Okay, it's the same. Now let's try to use 8, digital 8, and then connect this thing in our breadboard J5. Okay, again, we deleted the initial wire, which is connected to pin 13, and now we have used the digital pin 8. Okay, so make sure it's connected to J5, the same column again, and then going back to our code, we simply press code here. Okay, click, and then remember we use digital pin 8. Okay, that's why we need to change 13 here. We simply press 8 in our keyboard. Okay, so pin mode 8 comma output, and then of course we need to change 13 also here, type 8, 13 here, type 8. Make sure every digital pin is actually the same. Okay, so we declare pin mode 8 comma output, and then we have used digital write 8 high and digital write 8 low. Then we can now go back to our start simulation. Okay, and then let's see if this LED is still working. Now you can see my LED is still working because we have the correct pin, and we also declared the correct pin assignment under void setup, and under void loop we have the correct pin assignment also, which is 8. So that is the basic part or the basic Arduino program. Okay, so I hope you can still follow. Okay, this is just the basic part. We will move on to the next part, which is the serial, how to use the serial monitor using this, of course, Tinkercad. But before I proceed with the demonstration on how to do that, let's just have a quick uh, review of what we have done so far. Let's just ask Ma'am Janelu. Ma'am Jen, do we have questions from our viewers?
Okay, so back to the virtual math. I have another question. It's a true or false question. Click true if you were able to see that your LED is lighting up. Okay? O, ang bilis. True daw. Yay! So earlier we had 8 students, no? 7 of them got it working. So meron tayong ilang percent ba yon? Wait lang, magko-calculator ako. Kay 88% of our students got it correct, and now we have our our day working. Because sometimes if you just draw it and you did not wire it correctly, madaya tingnan, Sir Dom, no? I want to know if it's actually working because sometimes like the small tiny green on the anode leg of the LED, they always forget to put that onto the breadboard in the Tinkercad. So it's not connected. So it should be working. So far there are 5 students who answered true. Okay, so I think we are having progress here, 63%. So my target always is 85% and above. That's the passing grade for me as a teacher. So 85% of the students should be able to do that. Okay, no child left behind. Okay, well, it's still live, and then we'll proceed, and later we'll check if others were able to do it. Maybe there's 3 more who are trying to troubleshoot. Okay, you can move on, Sir Dom.
Okay, cool. Thank you, Ma'am Jen. So going back to our demonstration, we are done with the first part, which is the LED basic program, and we proceed with the second part, which is I'm going to show you how can we use the serial monitor to display text. Then right after that, we are going to use the sensor and of course the potentiometer and the servo. So I'm going to stop simulation now, and I'll add a new code, which is the serial dot begin 9,600 here. Okay, so this thing here will actually, it acts like a bridge, a connection between our Arduino board and our computer. Okay, this is the baud rate. The serial that begin 9600. 9600 again is the baud rate. Okay, and here under void loop, we can simply type serial dot print ln, and then let's try to add falta dash Arduino demo. Okay. So we have here serial.println falta dash Arduino demonstration. This means to say that whatever is inside this the quotation marks or the quotations, then it will be displayed in our screen. Okay. The reason behind this is because we have called this a function serial.begin or serial.println to display the text. Okay, so whatever text is inside these two quotation marks here, then it will be displayed in our screen later on. Okay, now I'm going to remove this code, also this one. All right, and delay, try to delay 1000 here. So, and then let's try to run or start simulation. Okay. Now, for us to be able to see the output, we simply click this arrow facing up arrow here on my lower right corner of the screen of my screen. And then you can see now that I have this Feltadas Arduino demonstration text printed every second. Okay, so you can see that Feltadas Arduino demonstration. I hope that is clear for everybody. Okay, so you can see the code. We have declared serial.begin 9600 and serial.println felt the dash Arduino demonstration. Okay, so whatever is inside the quotation marks, then it will be simply displayed in our screen. Okay, so for example, stop simulation. I'm going to add another text. Okay, copy this thing and print, and maybe we can type here hello world. This famous line, hello world. And then let's try to start simulation again and clear. And you can see there's a Felta Arduino demonstration and then the text hello world. So every second Felta Arduino demonstration will be printed, then another second hello world will be printed. So that's how you use a serial monitor to print text in Tinkercad. I hope everyone can still follow. Let's try to ask Ma'am Jen. Do we have questions from our viewers right now?
Ah, wait lang. So earlier, 7 out of 9 is working. So yung dalawa, nawawala. Okay, try ulit. True or false? Ulit ang aking question. Were you able to see the feed from the serial monitor? So if you are confused kasi medyo maliit, Sir Dom, no? So that's print line. So that's print lowercase l. Hindi po yan
Yes.
1. That's the common error kasi when they type. That's serial.print ln. Tama? And then remember to put the quotation marks. Okay, and of course, ang mahiwagang semicolon. If there's no semicolon, then it's not going to work. Okay, so I think they're still working. We'll give you 1 more minute. Okay, I have 2 students who got it already. I have 9 na. Oh, padami. Every time we open, we're adding 2 people. So by the end of the class, probably get them all in. Okay.
Okay, that's great. We have students who can actually um, follow our demonstration right now. So
Yes.
that's pretty quite good.
Okay. Yeah, 3
I
done
can
na.
see here in our live session right now, we have viewers in our YouTube channel and also in Facebook. So I hope guys you can it's free. You can actually join the classroom, Socrative classroom. Okay, you simply type b.socrative.com login/login/student and type the code. I think the code is virtual math. Yeah. Okay. So shall we proceed, Ma'am Jen, with the next part?
Okay. Wait, do they have to save as now, or can they still use the same plate?
Yeah, they can use the same file, but then it's up to them, ma'am, to create a new file if they wanted to.
Okay, okay. Just making it
All
clear.
right.
Okay, sir. Thank you. See you later.
Okay. So going back to our demonstration, we're done with the LED and the serial monitor. And for this second part or third part of the demonstration, I'm going to show you how to use a servo. Okay? So, ano nga ba tong servo? Usually, ang servo ginagamit it's like a motor, it's like a DC motor. Okay? Ginagamit to usually to automate or to automate things like yung kamay ng robot. So, ang servo usually madalas nakikita sa kamay ng robot. Ang servo madalas nakikita rin in malls. Okay? Wherein if you tap in, okay, let's say for example, you're an employee and meron tinatawag na turnstile, okay, if you tap in, if you enter the mall or your office, for example, meron yung turnstile na magbubukas. So, ang gamit po doon is like a servo. Okay? So, nag-automate siya. Okay? So, now, I'm going to create a new file. I think I need to create a new file. Okay? So, for us to be able to create a new file, you simply click the logo of Tinkercad. Okay? Don't worry, everything will be automatically saved. Okay? Once na nag-exit tayo sa mismong editor natin, automatic yun na nasa-save. Okay? So, yan. Click lang po natin yung logo ng Tinkercad. And you can see now the latest file that we have created a while ago. We have here the Falta-Arduino demo. So, which means to say it's actually saved. Okay? Then now, let's create a new circuit. All right? So, again, create a new circuit. Simply press create new circuit. Okay. There. So we have a blank space right now. And let's try to add a servo, an Arduino Uno, and of course, a breadboard. Okay. So here, let's look for the Arduino. Simply select the Arduino Uno R3 and drop it in our drag and drop in our editor. And of course, we need a breadboard. Look for the breadboard here. Okay. Select and then drop in our editor. And next, we have the micro servo. Select and drop here in our editor. Okay. I'm just going to rotate this thing. Okay. All right. There you go. So yeah. So this is our servo. This is a 90-degree servo. Okay. You can see in my screen there are actually three wires. We have the orange one, the red, and the brown, which means to say that this thing here, this wire is actually the negative, and the red is positive, and then this is the pin out. Okay, should be connected to the digital pin. Okay, let's just wait for our viewers. Yes, Ma'am Jen.
Ayan.
Waiting
Wait lang.
for.
Yeah. Let's wait because I even did it myself, and I just had the servo in. So if I can do it that fast, and then those who are beginners should be able to do it times two or three the time.
Yes,
Okay.
correct.
So do they only need one micro servo, right?
Yes, ma'am.
Okay, cool. So we just need for convenience, you don't have to follow us, no, because sometimes their screen are small, dom, so they cannot see it in landscape. You can always put the breadboard below the
Yep.
or
Here.
the Uno board, no. So
Yes.
which
Correct.
however comfortable you are, you're the master, you're the captain of your ship. Do it at your convenience and lay it out as comfortable as you can be, no? But make
Yes.
sure when we teach it in the classroom, we always remind the students to clean your wires and always color the wires so it's easier to troubleshoot. Yan. Okay, I'm going to ask again. Um, True or false? If you are done laying it out, kindly say true. Alright, I got one, two. There are 9 in the classroom. 7 are actually using the classroom. 2 are I just opened the classroom. So this is how good we have virtual math in. You can actually see sometimes they're there but they're not there. It's the same as the actual classroom. They're physically present but mentally absent. Okay. Okay, so I have one student who are still working on it. Okay, have yeah. Okay. Let's wait for that one now. Okay. So we have 6 out of 8. So we're waiting for one more to answer. Okay, 83%. Okay na yan. Kahit kulang 2%. We can proceed to the next one. Okay. Laters.
Okay, that's great. We have um 83% according to Ma'am Jen. Now, we proceed with the actual code of this circuit. But before that, make sure we connect all the necessary wires, okay, in our Arduino. So again, make sure you have this uh, servo here, okay. Then first we need to connect, okay, this ground to our breadboard. Ground means negative. Then we need to connect this thing here in our negative. Okay. I just changed the orientation of my setup because, as mentioned by Ma'am Jen, so some of the viewers are actually using an iPad or tablet or cell phone. Okay, and now since it's connected to our breadboard negative, then we make sure to power also our servo and make sure it's connected to our positive in our breadboard, just like this thing. And of course, do not forget to change the color of our wire and make it red if it's a positive, and if it's negative, it should be black. Okay? And of course, we should not forget also to connect GND in our um, breadboard. Okay? And also we have the 5 volts here, connect here and change the color. Sorry, it should be red and this one should be black. Okay? I think it's already connected successfully. We have here the GND connected to GND here, the positive connected to the positive of our servo. Then the next thing to do is, of course, connect this signal to our digital pin. Okay, so let's maybe choose digital pin 9. We can choose pin 9. Okay, and no need to change the color of our wire. Okay, now quick question: does it matter if we choose 6, 7, or 8? Well, it doesn't matter what pin you wanted to use, okay, as long as it's a digital pin. But are we going to declare pin mode -9 in our program? The answer is no. Okay. This sign here means that there is a specific function of this certain pin mode or pin. Okay, digital pin. So for example, gumamit kayo ng sensors, other components. So once you plug in your sensor in this pin assignment or in this digital pin, automatic yun, na na-detect ng ating Arduino na sasabihin niya, this component is this kind of sensor. Which means to say, may special function yung mga sign po na ganito. Okay? Meron siyang special na function. Okay? So, making sure that we have the correct wiring, let's have a quick review. We have the digital pin 9 connected to the orange or the signal. We have the red wire connected to the positive. We have the black wire, which is the ground, connected to our negative. Okay? Next thing to do is we proceed with the programming. You press code, and then again, blocks, make it text, and then just press continue. Okay. Here you can see our default program, but don't worry, we simply change the program. Okay. We remove this pin assignment here. We remove this code here. Okay. Now, since we use the servo, and that's a new component, we need to declare the library of our servo. To do that, we simply type the number sign followed by include less than sign, and then we need to type the servo dot h, and then the closing or the greater than sign. Okay. Again, it's number sign include servo dot h. This means to say that since we're using a servo new component, then we need to call the library for that particular component. Okay. Now we declare the name of our servo. It's like declaring a variable. It's a declaring component. So we need to use servo and then think of a unique name for your servo. Let's say my servo, and then followed by semicolon. Okay. We have the my servo followed by servo my servo. Okay. Then
Okay.
under void
Hold on
setup.
lang, Sir Dom. Saglit lang, Sir Dom. So, there's a question. How to change orientation po?
Okay,
Just
cool.
lang, quick lang. Thank you.
How to change orientation? For example, you want to change the orientation of your servo. You simply select the servo, and you can see here in my screen upper left corner, rotate here. Okay? Click nyo lang po yan yung icon na yan. And then you can see po na nagbabago yung aking servo. Okay? You can see here. Ayan. Nagro-rotate po siya. Ayan. I hope you were able to follow. Okay na po ba, ma'am Jen?
Yan, okay na. Thanks.
Okay. Yep. Sorry, hindi ko kasi nakikita yung mismong chat. Yung mga questions. So, si Ma'am Jen yung nakakakita. Alright. So, sasabihin lang ni Ma'am Jen kung stop, kung may mga katanungan po kayo. Well, if you have questions, type nyo lang po sa ating chat room or chat sa YouTube or sa Facebook. Now, going back to the code, simply select the code again. Since we're done with the declaration of our variable, we have here the servo already. Then let's proceed with the void setup code. We need to declare the pin assignment of our servo. Remember that we use the digital pin 9. So we simply type my servo dot attach 9 followed by semicolon. This line, the meaning of this line is actually we are declaring the pin assignment of our servo, which is connected to pin 9. If we used a different pin assignment, then please change also the pin assignment 9 here. Kung ginamit niyo 8 or 7 or 10 or 11, it should be the same, okay, in your program, okay? My servo here is the same with the my servo here. Attach means it's actually attached, diba? Connected to our Arduino. That's why it's my servo that attached. Under void loop, okay, here later on, we will type the program wherein our servo will repeatedly or continuously moved. Okay, but for the meantime, let's just type our code inside our void setup. Okay, now to move our servo into a different degree angle, we simply type my servo dot right followed by our desired degree angle. For example, 0. Okay, followed by semicolon. Okay, and delay, let's say 100 followed by semicolon. Okay, so copy paste para lang makita natin na may changes. My servo right, let's say 50. Delay 100, let's change this to delay 500. And then copy paste again. going back to 0. Let's type delay 500 here. So ano yung kalalabasan ng ating program? Initial state of our servo, since nakikita po natin yan, 0. Okay? And then after 100 milliseconds, mag-move siya 50 degrees. Delay 500. After 500 milliseconds, mag-move siya going back to 0. That's for 500 milliseconds also. Okay? So try po natin na i-check kung nag-work ba yung program natin. So medyo kinakabahan ako, baka hindi mag-work. So start simulation natin. And there you go. You can see the movement of our servo. Stop simulation, start simulation. You can see the movement of our servo. Very quick lang siya. 0 state, and then 50 degrees, and then move going back to 0. So nagano lang po siya. So again, start simulation. Bakit po hindi siya nag-move continuously? Why do we need to press stop simulation, start simulation? The reason behind this is because yung ating program po ay nakalagay sa void setup. Remember yung explanation natin a while ago that whatever is inside void setup, isang beses lang po niya i-run. Okay? Isang beses lang i-run. So paano natin makikita ulit? We need to reset the program or we need to simply press stop simulation. Using the actual Arduino kit, ipapress lang natin yung reset button, yung red na sinabi ko kanina ito. Para sa ganun, mag-work ulit yung ating program or gumana yung mismong gusto nating functionality. Now, kung gusto natin na paulit-ulit siya nag-move, then we simply remove our code and what shall we do? Put it inside our void loop. Okay? Lagay lang po natin sa loob ng ating void loop. And then now, simply start simulation. You can see now in my screen that my servo is actually moving continuously. Okay? So that's how you use a servo motor. It's the same even if it's at 90 degrees, 180 degrees, or continuous servo, or 360 degrees. Oh, the same po yun. Walang pinagbago. Okay? Ayan, so moving na po yung ating servo. So, check lang po natin kung may mga katanungan from Ma'am Jen. Ma'am Jen, do we have questions from our viewers?
Okay, hold on. So there is none. So if you go back to your Socrative, I did put, can you follow any questions? You can follow, say yes if you have questions. Type in your questions, please. Yan. Si Sir Wax, yes. Si Atomos, yes. Okay. Gonna, let's wait. So far, walang question. I think they're practicing. And then if you, you can tweak, no? You can change the, what you call it, the angle. Okay. Yeah. The angle of the, and you can also practice with the delay. If you want it to move faster, you can, decrease the number on the delay. If you want it to go slower, you can increase the number.
Correct. So let's just show them, ma'am, no?
Yes.
Delay, maybe we can make this 1,000. And for the delay here, let's make it around 3,000. And for the delay here, let's stick with 500. And start simulation. Stay. So mag-stay po yung servo natin on that degree angle ng ganung time. So yung interval niya is 3,000. So mag-stay po siya ng ganung katagal. Okay? Ayan.
Sir Dom, can you zoom in daw? Because they
zooming.
can, yeah, don't know the what you call it, the program, the code.
Ayan. Ayan po. Okay na po kaya to?
Yeah. May ilalaki pa ba yan?
Lakihan pa po natin.
You can.
I think I need to put this in Notepad.
Yes, I think so.
Alright.
Yeah, so for those who can see it.
Yan. Can you see my screen now, ma'am? Notepad.
Yes, yes. Yeah, I think they're good now.
Okay. All right. So I think we're good with the servo. Diyan, no? Pwede na tayong
Yes po.
mag-proceed sa next, no? Now, I'll be showing you how to control a servo manually. What if gusto natin na kinokontrol natin yung movement or yung pag-ikot ng servo? How to do that is going back to our main circuit design, we simply need to add a new component, which is the potentiometer. So hanapin po natin yung potentiometer sa ating components here. Okay? So potentiometer, here is our potentiometer. Okay? So parang ito yung tinatawag na parang ano man tamang term dito sa pag nakalimutan ko yung term, ma'am, dyan, yung potentiometer. I think familiar to sa mga sa mga radio na device. Iniikot siya. Ayan. So
Oo,
nababago
lab.
natin, no? Ayan. So potentiometer, gagamitin po natin to control our servo. Kung ano yung ikot ng ating potentiometer, susunod dapat yung ating servo. Okay, simply this is automation still. Okay, kanina is autonomous, now gawin nating manual. Okay? So ilagay natin si potentiometer sa ating breadboard. Okay? So breadboard, ilagay po natin dito. Maybe I can just rotate this one para parehas po tayo ng screen later on. And then ilagay ko na siya dito. Okay? Ayan po. Ayan. Then again, meron pong tatlo na wires na kailangan nakakonect yung ating mismong tawag doon, potentiometer. Okay? Yung ating terminal 1, no? Terminal 1, this should be connected to our ground or negative. Okay? So click natin to, yung sumunod na butas, no? And then connect this to our negative. Ito. Ayan. Change natin kaagad yung color para hindi kayo malito. Again, black is negative. Ayan po. Connected po siya sa negative. Ito po siya. And yung next po na kable is yung nasa gitna. Okay? Yung nasa gitna po, kailangan connected po siya sa mismong analog na pin natin. Okay? So, itong gitna natin, okay, should be connected to our analog. Okay? Ayan, don't be confused. Lalagay ko po siya sa analog 0. Medyo nag-overlap po tayo dito kasi yung orientation ng ating circuit, no? So, ayan. Change natin tong color nito. Gawin nating blue para maiba naman. Ayan po. Okay? So, nasa analog 0. And then lastly, we have the terminal 2 should be connected to positive. Ito. Ayan. Change natin to red. Ayan po siya. Refresh. Tatlong wires ang ginamit natin para sa ating potentiometer. Ni-rotate natin yung potentiometer natin. Terminal 1, yan po yung negative. Then should be connected to our negative sa ating breadboard. We change the color, the wire color to black. Yung nasa gitna, again, that's the signal or yung wiper natin. That should be connected to our analog pin in our Arduino. So analog 0 yung ginamit po natin. And lastly, we have the terminal 2 should be connected to our positive wire or positive na breadboard natin. Okay? So, complete na natin yung wires. Then the next thing to do is to proceed with the program. So, magpo-post muna ako ng mga maybe around 20 seconds para makita niyo yung actual na circuit. And then, habang iniintay ko po kayo, okay? Ayan, pakita ko na po yung code natin. Okay? Ayan. So, I think, ma'am dyan, no? Okay naman tayo so far? Nandiyan pa po ba si Ma'am Jen?
Yeah, yung code. Nakamute ako, sorry. Daldal ako ng daldal, nakamute pala. Okay, so they were saying bigger codes ulit. Of course, yun pa rin.
Yes.
No question. They can follow. So, finish ko ulit. Tapos bago ako.
Okay. Alright. So, pwede na tayo mag-proceed, ma'am, no?
Mm-mm.
Yep.
I have the live question on the virtual math classroom. No, if they can follow or they have questions, they can ask there also. So follow through. Continue po.
Okay, follow, sundan niyo na lang po ako, no? Now, simply delete this code here. Itong mga codes na to, hindi na po natin kailangan to. Kasi ang gagawin natin, kailangan yung ating mismong servo ay gumagana sa pamamagitan ng pag-control sa ating potentiometer. Okay? So, dapat gagana yung ating servo gamit lamang ang potentiometer. Okay? So, check lang po natin yung ating, do not forget to check yung ating analog 0 here. Okay? So, yep. Next is, kailangan na po nating declare yung ginamit natin na servo sa mismong program natin. So, ay yung mismong potentiometer na ginamit natin. So, maglalagay ako ngayon dito ng another variable. Okay? So, ang gagamitin kong variable name is pot value. Okay? Then another variable name is int degree. Okay? Now, ano naman tong dalawang variable na dineclare natin? Itong unang variable natin na to, pag sinabi natin muna, no? Pag sinabi natin int, ang ibig sabihin po ng int is an integer. Which means to say, ito ay decimal value or decimal number. It doesn't mean to say na kapag decimal merong point or yung decimal places. No. Decimal value, since it is a positive, negative whole number. That's why it's an int or integer. So, gagamitin natin ang pot value para sa ganun, makuha natin the value of our potentiometer. Kung ano man po yung laman ng potentiometer habang iniikot natin yung potentiometer natin, nilalagay natin yung value na yun papunta sa ating variable pot value. Now, kung medyo nako-confuse kayo sa pot value, you can just use X. Okay? Pwede yung gamitin si X. Kung gusto yung gamitin si X, pero ako ayaw ko nang gamitin si X, gamitin ko na lang pot value. Proper naming convention. Kung para saan nga ba yung proper naming convention? Para sa ganun, kung marami tayong components and variables, hindi tayo malilito kasi alam natin kaagad kung ano yung gamit ng variable na yon. Since it's pot value, then potentiometer value kaagad yon. Next, itong degree naman, ito yung mismong degree ng ating servo motor. Kapag inikot ko si potentiometer, ibabato natin yung value ng potentiometer papunta kay pot value. Ngayon, si pot value naman, ibabato natin yung pot value papunta kay degree. Si degree ngayon, i-convert natin siya. No? Yung pot value, i-convert natin into degrees. Okay? So medyo nakakalito, pero kapag nakita nyo na yung program, masusundan nyo naman po siya. Okay? Of course, under void loop, okay, under void loop po natin, kailangan lang natin i-type ang pot value followed by equal sign, map. And then, ano bang ibig sabihin ng map? Okay, no, not map pala. Pot value, itong pot value na to, itong variable, okay? Pot value and then analog read. And then, ano ba yung analog assignment na ginamit natin para sa ating potentiometer? Yung analog na ginamit natin, remember, it's the, going back here, it's the analog 0. So, dapat ang nandito sa loob is analog 0, A0. Hindi po siya AO, but it's analog 0. Yan po siya. So, type natin ang analog 0. Okay? Now, gamitin muna natin tong serial.println para i-display yung value ng ating potentiometer. Lagay natin dito ang pot value. Para lang sa ganun, guys, nakikita nyo yung output talaga. And then, maglalagay ako ng delay. Not delay 1,000. Maybe delay 100. And here, wag natin kalimutang declare ang serial.begin 9,600. Again, ito ay, you don't need to do this. Ipapakita ko lang yung mismong value ng potentiometer natin, okay? For the meantime. And then start simulation natin to. Okay? And then, click natin yung Ito, kita nyo po, no? Yung pot value natin, 0. Ito po siya. Okay? Ito mismo. Okay? Pero, kapag ginalaw ko na yung potentiometer, as you can see in my screen po, no? Ito na siya, 164. Habang iniikot ko po siya, nagbabago din yung pot value. That means to say, binabato ng potentiometer yung value niya papunta sa ating variable na pot value. Again, yung pot value is just a variable. You can just change that. Okay? Ayan, so iniikot natin to. Nagbabago din yung potentiometer dito. Ngayon, ang gusto natin gawin, kapag inikot natin yung potentiometer, ganun din yung ikot ng ating servo. But remember, ang ating servo po ay hindi aabot ng 511. As you can see in my screen. Kasi 90 degrees lang po siya. Or simply, ito yung servo na SG90 ang tawag po doon. So, pwede siyang umabot ng 90 or 180. Okay? SG90, pero hindi siya 90 degrees lang. Pwedeng mag 180. But not 360. Okay? That means to say po, no, na kailangan nating palitan yung ating mismong pot value or potentiometer frequency ito or resistance ito. Select natin yung resistance or yung mismong potentiometer natin. Again, na-click ko po siya. And then dito sa resistance, gawin po natin siyang, let's say, 90 for the meantime. Para sure lang tayo, no? Tinype po natin 90. Which means to say, yan yung maximum value. Okay? So, tinype natin 90. Okay? Going back here, select, and then type 90 here. Then, balik po tayo sa code. Okay? Code. Now, start simulation natin. Clear lang natin to. Okay? Yan. So, 90 na. Dapat mamaya, ang maximum na lang neto ay 90. Kapag pinindot na natin siya. Okay? Dapat, yun na lang yung lalabas. Okay? Mamaya. Okay? So, start simulation lang ninyo later on. Okay? Stop simulation natin. And then, clear natin to. Remove natin to. Okay? Now, ang gagawin na natin is to connect or to control our servo using this potentiometer. Okay? Sa ngayon, kailangan nating i-remove muna tong serial.println sa delay. And next code natin is to convert our pot value or the value of potentiometer, convert na natin siya into actual degree. Okay? Actual degrees. To do that, we simply type sa program natin ang tinatawag natin na degree. Ano ba tong degree na to? Ito yung variable na nandito. So, degree is equal to map. Ito yung code para i-convert yung pot value, row value, into a degree angle. So, map followed by, sorry, pot value. Ayan. Again, yung pot value natin, guys, yan po yung galing sa potentiometer. Okay? Pot value, comma, 0, comma, okay? Lagay natin ng space para sa ganun, hindi tayo malito later on. Space. Ano ba yung frequency na gusto natin? Or ano yung resistance na gusto natin? 90. 90 lang yung resistance na gusto natin. Okay? Okay? And then, 0, comma, space, then let's say 120 dito. Yung ikot niya. Okay? So, pwedeng, ang resistance natin mas higher, pwedeng let's say 1023 or let's say 1,000. It's up to you. Pwede nyo lang palit-palitan to later on. Okay? But nakaka-apekto ang mismong resistance or mismong ikot ng ating degree. Ito yon. Ito yung nakaka-apekto. Okay? Kailangan, ang max lang nito is 180. Pwede po natin gawing 90 to. Okay? And then semicolon here. Balik po natin to sa dati. Pwede natin gawing 90 again or 1023. Kung ano po yung resistance na nilagay natin kanina. Okay? Since ang nilagay natin dito kanina, kung natatandaan po ninyo, ay 90. Okay, ito 90 po. 1023 natin or 250 natin. It's up to you. Basta, ang importante po, yung nandito is less than the degree angle na kayang gawin ng ating pot value. Which means to say, dapat naka-match lang siya sa kung gaano iikot yung ating servo. So, since 120 lang to, okay na po yan. Kasi sabi ko kanina, 180 pwede. And then next is, maglalagay na tayo ng my servo. That's right. Followed by degree. Again, wala sana ako nagtatype. my servo, that right? And then, yung mismong degree na na-convert natin. And then, of course, yung delay natin. Maglagay lang tayo ng short delay. Let's say 50. Ayan. So now, ang mangyayari po, pag inikot natin yung ating, I think natanggal ko yung aking potentiometer, no? Sorry, ibalik ko lang. Ayan. So, ang mangyayari po, sa code natin, zoom ko lang po. Ang mangyayari dito, first part, kukunin natin yung value ng potentiometer, ilalagay sa variable na pot value. Second part, i-convert natin yung pot value papunta sa degree. So, para ma-convert, kailangan natin itong map na function. And then, of course, yung resistance natin, followed by the starting degree angle, and then ending degree angle natin. Hindi pwedeng sumobra sa 180. Okay? Followed by my servo.write degree. Itong my servo, ginamit po natin to kanina para mag-move na mismo yung ating servo. Delay is kung gaano kabilis or kabagal mag-respond yung ating servo depending sa pag-ikot ng ating potentiometer. Okay? Now, I think we are ready to run the program. Press natin yung code. Zoom lang natin po ito. Okay. Ayan, para makita po ninyo mabuti. And start simulation na po natin. Sana mag-work kung may nakalimutan man tayo o wala. Now, try natin i-move itong servo natin. Ayan. Napapansin nyo po, no? Ayan, minumove ko siya. Etong part na to, kahit isagad natin, ibig sabihin po niyan, 120 pa rin yan. Remember yung program natin? Yung sa dulo, 120? So, ang start ay 0 up to 120. Ibig sabihin yung resistance ng ating servo from 0 to 1023 or 0 to 1023, ginawa natin, convert natin siya at binawasan ng starting 0 to 120. Kaya kapag iniikot ko to, hindi aabot ng 1023. Kasi, kinonvert na natin. Ayan po siya. So, umiikot, sumusunod din po ang ating servo. Okay, ayan po siya. Ayan, so I hope nakakasunod yung iba, no? Balik lang natin sa code para sa ganun makita. Copy ko lang po to, ilagay ko lang dito sa mismong Notepad++ natin. Okay. Sige. Ma'am Jen, meron po ba tayong mga katanungan from viewers natin na kailangan i-clarify?
Ayun, no? Actually, I asked them already in the virtual classroom. I think they're still typing. Yeah, we can have the code flashed bigger, I guess.
Okay na po
Move
kaya ito,
sa
Ma'am Jen?
sa
Nasa
send.
Notepad++ natin?
Wait lang. Yeah, I think. So, can you, ayan. Hihilo na daw. Medyo, mga teachers natin are so tired, no? It's already a Saturday. So, ang dami daw nilang work because they're doing the lesson exemplars, but they are continuing. Sir Wax said, I feel good. Still working, Ma'am Gemma. Congratulations. The struggle is real. Okay, so far, they are working. Just to clarify, Sir Dom, no? So, degree equals map. So, the mapping, no? There are, can we name the 5 parts of that? So, the pot value is the variable name. Can we have it for those who are new? Kasi, para sure. So, the first value is the...
Ito pong pot value, ma'am.
Mm-mm.
This pot value here is actually the variable name na kung saan kinukuha natin yung mismong value ng ating potentiometer. Here, you can see here we have the int pot value. This is just a variable. Pwedeng ABC to.
Yes,
so, itong
correct.
pot value, kapag nakikita nyo po, naka-highlight din yung pot value na to. So, it's connected. Okay? So, itong pot value na to, yan yung value ng analog A0.
Correct.
Okay? Yung analog A0 natin, you can see here na my screen, ito po siya. Galing po yan sa ating potentiometer.
Okay.
Yan yung signal. Analog signal. na nanggaling sa potentiometer na nilipat natin yung value niya papunta sa isang container na pot value ang
Correct.
pangalan. Ngayon, dito sa degree, sorry, yung degree naman to another variable wherein
Mhm.
ito po yung mismong variable na kung saan i-convert na natin yung raw value from our potentiometer. Okay?
Correct.
So yung raw value na yon, i-convert natin into a degree angle. Ngayon, itong degree angle na to, since ang ating potentiometer ay sobrang laki ng value, so itong map na to is a command na nagsasabi na ang pot value natin, ang pot value, remember, the pot value is just a raw value na hanggang 0 to 1023, instead na hanggang 1023, i-convert natin yung 1023 na yan papunta into a lesser value which is 120. Which means to say kahit naka-max na yung potentiometer na maging 1023 na ma-reach niya, still, magiging 120 lang yun. Kasi
Correct.
naka-declare dito 120. Pansin niyo to, itong unang 0 na to, ito yon. Itong 1023 na to, ito yon. Kino-convert natin itong 1023 to 120. Pwede pong 90 to. Okay?
Yes.
Kung minor natin ng max yung ating potentiometer, 90 degrees lang nung katumbas nun. Okay?
Okay, correct. Then,
Yun
that
po.
is very helpful. Remember that your servos come in different angle maximum turns. Kaya baka ang nabili nyo 180 lang, pinaikot mo ng 360. So, magka-crack. hindi na siya aabot to. So, you're expecting a 360 tapos you connected a 120, 180 na servo. So, it's also paying attention to details for students, knowing the specific parts that they're placing and getting specific yields on their codes. Okay, so Ma'am Gemma says may error po ang akin code. Ayan nga. The problem with teachers, we're looking at the screen almost 24/7 na. That's why we are getting typos na. Okay, so far they're good, sir. But we can go to the next, I believe.
Okay. I think last part na tayo, Ma'am Jen. Yung mismong distance sensor natin.
Okay po.
Analysis po, no? So magdi-distance sensor na tayo, which is kailangan na natin ng conditional statement po doon. Okay? So I hope nakuha niyo po ito. Pwede kayong gumawa ng panibago na na file or pwedeng ito naman yung gamitin niyo. But for me, I think gagawa na lang ako ng panibago. So click ulit yung mismong logo ng Tinkercad. And of course, kailangan kong gumawa ng panibagong circuit. Create new circuit po tayo dito. Press lang po natin yung create new circuit here. Ayan. So panibagong file na naman tayo. No? Pwede yung palitan to. Gawin natin na Delta Dust Distance Sensor. Okay. Ayan. Then, of course, the same procedure. Add tayo ng Arduino Uno. Add tayo ng breadboard. And now, mag-a-add tayo ng hanapin natin yung distance sensor. Ito yung tinatawag na ultrasonic distance sensor. As you can see here. Ilalagay ko ngayon siya dito sa ating breadboard. Dito na lang po. Ayan, you can see. Yung ating distance sensor po ay meron siyang different parts. Okay? We have here yung ating GND, the 5 volts, and the signal. Okay? Tatlo lang po. Ito ay a parallax ultrasonic distance sensor. So again, yung ating GND should be connected to negative. Connect natin sa negative to. Black. And then, this is red. And then this signal here, kailangan dalhin po natin to sa ating digital pin. Okay? Yung digital pin natin, pwede tayong gumamit ng digital pin. 9 maybe? Yan. So pwede naman kahit anong digital pin po. But I choose 9. Ano bang meron sa 9? Wala naman po. Sige. Now, mahaba po yung program nito. Okay? Totally mahaba. Para mabilis natin maintindihan yung conditional statement, ang gagawin po natin, ituturo ko sa inyo kung paano kumuha ng codes from Arduino CC. Itatype lang po natin sa ating server or sa ating browser ang arduino.cc. Okay? arduino.cc. Ito po siya. Okay? Ngayon, dito sa arduino.cc, marami kayong makukuha mga tutorials and materials also. And, of course, search po natin yung mismong tawag doon as distance sensor. Type po natin ang distance sensor. Ayan, yung ping. Ayan. So, pag type nyo ng distance sensor, makikita nyo ang mga iba't ibang projects gamit ang distance sensor. Ayan. Para sa ganun, mas maintindihan nyo po yung mga, ano bang gamit ng distance sensor? Okay? Ayan. Ito po siya. Sobrang dami po. Ayan. Ngayon, gaya ng sabi ko, since sobrang haba ng code ng distance sensor, ang gagawin ko ngayon po ay I will show you how to simplify yung code. So punta tayo sa google.com. Hanapin po natin ang distance sensor. Type natin distance sensor ping. Ayan. Arduino distance sensor ping. Pwede po natin i-type yan. And then lalabas po ulit yung distance sensor natin dito. Click lang po natin yung ping. Ayan, ito na po siya. So, ito, makita yung explanation ng gamit ng distance sensor. Paano i-calibrate or paano paganahin yung mismong distance sensor. Okay? Yung circuit, nandito rin po yung explanation niya. So, you can see here na ang ginamit na assignment, I7 here. And ang ginamit ko naman, I9. Walang problema doon. Okay? And of course, going back here, yung schematic diagram. Okay? And yung code, nandito rin po yung code niya mismo. So, ang gagawin po natin, we will simply copy the code kasi gaya ng sabi ko, sobrang haba po ng code. Okay? Para sa ganun, ma-explain ko lang sa inyo yung parts ng code. Hindi na natin ita-type. Okay? So, this is free. Wala naman pong copyright to. So, simply copy. Okay? So, copy natin tong buong code na to. Okay? So, select everything and then copy. Okay? And then going back to our Tinkercad, press code, text, continue. Ayan, then tanggalin na po natin lahat to. Select everything and then paste.
Nawala audio mo, Sir Dom. Okay.
I think meron pong inquiry. Yan, nire-remove ko lang po lahat ng comments. But I will explain these codes here. Okay? Ayan, so sobrang haba po ng code nito. Okay? Now, okay, before we proceed with the program, do not forget, again, yung power ng ating Arduino papunta sa breadboard natin. So, negative. Again, kuha tayo ng negative value here. Yung positive, connect din natin yung positive. Change natin yung color. Also, this one, gawin nating black. Ayan po. So, okay na to. So, ito na yung code natin. Okay? Ma'am Jen, nandyan po ba kayo? Quick question lang po kung nasundan po nila yung circuit design natin para ma-explain ko na po yung code natin.
Okay, so yung isa nating ground ay nasa ground. Ay, yung ating positive ay nasa ground, Sir Dom. Sa baba.
Sorry. Ay, yeah. Thank you.
Yeah. Okay,
Gawin natin
baka mas
to.
short. Okay.
Sorry.
Okay lang. May nag-comment kanina, nag-send sa akin ng photo kasi hindi niya talaga makita. No, it's really hard to find the bugs sometimes, nakakaduling. Okay, so sometimes you're missing closing bracket or like parentheses. Sometimes you type in double. So, yung close parentheses ay na doble, Ma'am Jem. Yan, so Ma'am Jem yan. Okay, so far, let me see if they have questions. Ayan. Pwede daw bang makopya ang code? Ipopost.
Paano natin ibibigay, ma'am? Ma'am Jen, i-copy-paste ko, then send ko sa'yo?
Pwede.
Okay, so StreamYard po, no? Here in chat, our chat.
The chat po. And then you can also doon sa Arduino link para hindi na sila maloka.
Yes, tama po. Ito po, mismo. Punta lang po kayo sa Again, ang tinype po natin kanina sa ating Google ay yung distance ping Arduino.
Ping
Ito lang po siya.
Arduino.
Oo. And then,
Distance
yung
ping
pinakaunang
Arduino.
link, arduino.cc, click nyo lang po yan. And then, copy nyo po yung code.
Correct.
Ayan. Copy lang po natin yan.
Yeah, this is the good thing about the Arduino learning, no? There's a lot of community resources. They are very friendly. So sobrang friendly. They give you more than what you asked for. So you just have to pick and choose which one works. And sometimes, especially if you are using white labeled boards, because not everyone can avail the original boards. No, there are some uh, applications. Your codes are correct, but the device won't take it because you need to install the driver. So sometimes the people and teachers even get frustrated. Even my college students get frustrated because they worked hard on assembly and they worked hard on the code. There's no error on the code, but the board is not accepting it. No, so it's really, really, really crucial that
Yes.
you take care of little details. So don't
Oh,
worry. There's a lot of community help, and you can ask our Dom as the expert. Ano ka?
yes, ma'am.
I can support you emotionally.
Yes, that's correct.
Okay, so far, so where can they actually use it in their sa smart cities? Saan ginagamit itong mga distance sensor, mga potentiometer?
Okay. Just to give you an idea, well, actually matagal nang ginagamit ang distance sensor. Sa mga
Correct.
sasakyan, when you park your car,
Mm-hmm.
merong siyang parking system na tinatawag that is actually using distance sensor. Pero hindi kagaya ng
Mm-hmm.
sensor na ginagamit natin. It's a different version. The same with sa mismong mga malls parking system, 'di ba? Meron parang
Yep.
light sa taas. 'Di ba
Mm-hmm.
pag green, ibig sabihin that is vacant. Kapag red, it's
Uh-huh.
occupied. Kapag
Yep.
papasok ka sa mga high-tech na malls or high-tech na
Mm-hmm.
establishments, kung saan magbubukas
Mm-hmm.
yung door, sliding door, it's because there's a sensor. Distance
Mm-hmm.
sensor na kapag nakapag-detect siya ng tao, then automatic na magbubukas. Or
Yep. So
tinatawag na
that's
this PIR sensor. It's possible na
correct.
PIR kasi thermal naman yung kinukuha niya. Ayan.
Opo. Ayan, pwede merge, no? So the distance sensor you can merge with the servo motor. So just like if it's a door, a sliding door or meron yung mga rolling doors, yung sa mga gates yun, no? So when sa mga gate ng bahay, when you are trying to get in, there's a sensor that actually detects if the car is coming in. And there are more specialized if that car is yours, then it will open. If the car is not yours, then it won't. So there are cameras where you can code that's a higher level, and there are a lot of devices to use for it. It's not just the Arduino. We can use the Pi and we can use other microcontrollers. So it's always a good start to familiarize with Arduino first. Is the most user friendly so far for beginners.
Yes. Of course, they can
Okay.
buy Arduino in Falta. I think meron ng Falta, ma'am Jen. Tama ba?
Yeah. Yeah, they
Okay.
have the guest that we have, Miss Mai. Let's call in Miss Mai. Miss Mai, are you there? Waksasan ng madam.
Ayaw ko papasok.
And
Yan, they
Yes.
were asking.
Yes. The Gearbox Labs is the authors of the Arduino classroom. So that's the curriculum, and then they also have mini sets, mini kits, which means if you only want to use, for example, the sound sensor, you can just get that. Or if you want a training kit, which is including all the other sensors, so we can also arrange for that. So we have training kits, we have competition kits as well. So all of that is available in Felta. So you just go to you can send us an email at Felta Multimedia Inc. Incorporated at gmail.com. Sir Wax can flash it. So the kits. Miss Jen, I just want to, of course, inform the public that there are certain sensors that are available only at the Gearbox Lab kits. Because as Peter Haydock has mentioned in our conversations, that there are common parts, of course, kasi Arduino is commonly it's found
Oh,
in
yeah.
many
Widely
many
used. Mm.
electronic stores, or especially here in the Philippines. But there are certain sensors and certain parts that are, I would say, proprietary to Gearbox Labs. So
Oh,
those
yeah.
are the salient points. Oo.
Yeah, they developed it themselves, no? Because they are the
Yes.
authors. They already
Yes.
have a plan for it. So, yan. We use it. Dapat pagpunta natin ng PhilTap, fully automated na si Mama Eileen, ano?
Oo.
Enough.
Hindi bali
Okay.
even for the schools kasi like
Mhm.
what Dom has been showing to us in the past hour and hour and a half, what you have been showing
Mhm.
us, these are now the, I would say, this is the future. So really have to win the future. It started here with these kinds of calls, these webinars. It's a new norm na how we were going to share our knowledge is going through digital format. Now, if they have the skills in the smart cities as we are showing them, they will also be able to develop the future engineers that we need and
Yeah.
roboticists. Mm.
Yeah, correct. And the good thing about them joining webinars like these also is you can buy a service provider service with the kit itself, but there's always that room for customization because not everything that you can buy commercially is fit for your needs. You have to add on or reduce, no? So,
Yes.
kailangan talaga you learn and not just buy. Because what will happen is you buy the very expensive one and then something comes up, eh maliit na servo lang pala. You just have to replace the servo and you don't know anything about it. You'll end up buying a whole set instead of replacing one part. So,
Yes.
yun yung advantage dito.
Mm-mm.
It's
Saka
always
yung
good thing
breadboard,
to know.
saka yung importante, you buy the quality kasi yung breadboard, yan yung laging nasisira, di ba? And then you just,
Yeah.
bibili kayo ng mura and then you just keep buying and buying and changing and changing. Parang bumibili tayo ng sapatos. Kailangan medyo quality naman. O. Palit tayo ng palit. Di ba? It's the same
Oh,
logic.
yeah.
You buy
Yeah.
quality. You buy for
Yeah. And
quality.
Sir Dom will show us ano pala, your actual kit. Tama ba,
Yeah,
sir?
yeah,
You
yeah.
have,
But
yeah.
yes,
Okay.
ma'am. But before that, I think yung just a quick overview dun sa Arduino kit ng Falta. I think meron atang book na kasama yan, ma'am, no? Para sa
Yes.
ganun, makakard
May
din sila.
curriculum. Yes. There's a
Mm.
curriculum which is, it can compasses from beginner up to advanced. So, hanggang college level siya. Meron. Saka bihira yung may nagsusulat ng curriculum ng Arduino. Actually, I think it's Gearbox Labs lang ang alam ko, di ba, Dom? Sir Dom?
Yes, ma'am. Yes, ma'am.
Parang nagsulat pa so far for
Opo.
for
Yeah, nakita ko
Arduino.
po yung book.
Yeah.
Sobrang ang ganda. Maganda yung book.
Mm.
Yung kasama niya na curriculum.
Sobrang ganda,
Very
bibigyan
informative.
mo daw kami ni Dom.
Very informative. Ayun.
Okay.
All right.
Sige.
Okay, let's look at
Thank you,
what
Ma'am
you
Marlene.
Let's proceed.
have.
Let's
Thank you,
proceed.
Mama.
All right. Ayan. So, what I did so far, I changed the ping assignment, the value here. Kanina, this is 7. We just copy-paste yung code galing sa Arduino.cc. So, this is actually 7 kanina. So, I changed it to 9. Kasi ang ginamit ko pong digital pin is 9. So, all you need to change is the pin assignment. No need to change the rest. Okay? So, hindi na natin papahabain yung kwento. Alright? Now, explain ko lang, quick explanation lang kung ano nga bang nangyari dito. Under void, this first line here is actually the declaration of variable, which means to say that the digital assignment, pin assignment is 9. Kailangan natin i-declare. So const means it's a constant integer, constant variable. That is an integer. Ping is just a variable. Now we use ping because it's the name of this is a distance sensor and parang ping. Nagpiping tayo, nag-ask tayo ng value. That's why it's ping. Pin is just a term which is pin, the pin. Okay, then the 9, which is the assignment, the digital assignment, followed by the serial that begin 9600. That means to say that this is the connection between our Arduino and our computer. Long duration inches centimeter. Long is another a type of data type. This is a data type which is long. It's like an integer. It's like a float, a string, or a character, but then it's a long. Mas mahaba siya sa integer. Duration is just a variable. Inches is just a variable. CM is just a variable. So we need these things here. It's because these are the variables that will what? Hold the value of our sensor. So ipapasa-pasa natin yung value ng sensor natin and we will convert the value of our sensor into different unit of measurements. You can see here, cm, inches, and the duration. At first, we can use inches. We can also use centimeters. Okay? Para sa ganun, may option tayo kung gusto ba natin gamitin ng inches or centimeter. And if you want to use kilometers, well, it's up to you. You just simply do the mathematical expression or equation. Okay? Then pin mode is the pin assignment, pin output. Output because ang ginagawa natin is we simply send signal. Nagsasend tayo ng signal sa sensor natin. And then right after sending the signal, ino-off natin yung ating sensor. Which means to say, may specific time interval na magsasend tayo ng signal. And at the same time, may specific time na i-on natin yung ating sensor. So, hindi tuloy-tuloy na naka-on at hindi tuloy-tuloy na naka-off. For us to be able to what? To extract the value. Parang ganito. There's a ball. Yung bola, ibabato ko. That's where you what? You turn on. Kumbaga. So, you send the signal. Ngayon, ibabato ko sa wall yung bola. Okay, may action talaga. Ibabato ko yung ball sa bola. Ibabato ko yung bola sa wall. Ngayon, the moment I throw the ball, yan yung sending the signal. Kaya naka-high. Ngayon, since pag tumama yung bola sa wall at babalik sa akin yung bola, that's the signal na nanggali sa mismong yung bounce, nag-bounce yung echo na tinatawag. So, nag-high na yung ating ping. Okay, nag-high na siya. So, ngayon, yung duration na variable, that's the interval. Halimbawa, binato ko yung bola. Let's say, ang tagal bago na-reach ng wall ay, let's say, 5 seconds. Pag bumalik sa akin yung bola, another 5 seconds. Ngayon, yung duration na yon 10 seconds in total. No, yung 10 seconds na yon, i-convert natin siya into what? Into distance. That's why, itong papakita kong sunod na code, ito po, duration is equal to pulse in, pin high. Ibig sabihin po ng line na yan, kino-convert natin yung time interval. Okay? Kino-convert na natin yan. Nag-i-start natin i-convert yung interval. Yung 10 segundo, yung papunta at pabalik sa akin, kino-convert na natin siya into distance. Okay? So, inches, ang unang ginamit natin dito na unit of measurement is inches. Microseconds to inches. Take note of the term to inches. Duration. This is simply a command or a function. Hindi na no need to do the mathematical equation, but simply using the reserved word or reserved function, microseconds to inches, mako-convert na natin yung time interval, yung traveled, into a unit of measurement, which is inches. At the same time, we can convert it to centimeters by simply using the microseconds to centimeters. Kung ayaw nyo pong gamitin din, you convert the inches to centimeters divided by 2.54. So, ganito lang siya kasimple. In short, kino-convert lang natin yung time into unit of measurement. Then, yung part na to, remember, yung serial that print natin is to simply display the value of our distance sensor. At yan lang po siya talaga. And eto na po, yung mga reserve natin kanina, it's because meron tayo yung mathematical expression dito na 74 divided by 2, 29 divided by 2. Guys, I don't need to explain this. As you can see, this is the command wherein we convert the time duration papunta sa unit of measurement. We don't need to change this kasi that's given already. Okay? Now, if I'm going to run this program, you can see here, na kapag click ko po itong part na to, okay? Litan ko lang po siya, no? Naka-start simulation, i-click ko po to. You can see the distance here, 49. And kapag mag-press ako, ito, This is the actual distance. Let's say etong bilog na to, ito yung mismong wall. Kapag nilalapit ko, you can see the distance become shorter. Ayan, habang lumalapit, of course, the distance nagiging short din siya. Ayan. So, minumove natin siya, lumalayo din yung distance. So, parang sa actual, no? Ganun din yung application niya. So, without using an actual Arduino kit, guys, we can use an ultrasonic distance sensor simply using Tinkercad. Again, it's free. But then, of course, if you want to hobbyist kayo or maker kayo, of course, kailangan din ng actual Arduino kit. The same program po ito. Ayan po siya. Okay, wala tayong binago. Ang binago lang natin sa code is just the pin assignment. So, I think it's working already. Then we go back to Ma'am Jen kung meron tayong mga katanungan. Then after ng katanungan natin, you can see, Ma'am, may demonstrate ko yung actual na board. I'm using Arduino Mega and yung ating water sensor and soil moisture sensor here. Ma'am, may flash ni Sir Wax yung aking screen, yung ating camera dito. Para sa ganun, may ipakita ko kung paano nag-work in actual Arduino kit. But kanina in the first part, nakita nyo na dinemonstrate sa atin ng Gearbox Labs yung mga different available sensors sa kanilang kit. Okay? So, Ma'am Jen, I think clear na po tayo or may mga katanungan?
Ayan. Ang tanong is, where do you connect the green circuit line? Sa pin 9. Tama ba?
Yes. Pin 9. Correct, pin 9 po. But then, in your code, sa program po natin na kinapi natin from arduino.cc, ang const int pin is equal to 7. Then you need to change that and make it 9. Okay?
Correct.
Since 9 ang ginamit natin, yun lang ang nag-iisang code na niremove natin, pinalitan natin ng assignment. So, wala na po tayong binago.
Yeah. Or kung ayaw mo magpalit ng code, magpalit ka ng pin. Ilipat mo sa 7. Diba? Okay, so I think ang sabi niya, thank you so much. Happy customer. One happy customer ulit. Okay, we have a live pa rin yung ating virtual mat. If you have questions, ask us now na. Okay. So, Sir Dom, may code kasi yan no? So, yung actual kit, there are codes for hindi naman code yung mismong type ng ultrasonic sensor because it comes in different ranges. Okay, so you pick the ultrasonic sensor based on how you are going to use it. For example, you are using it for a sumo bot. Okay, why would I buy a 12 feet range na ultrasonic sensor to put in my sumo bot if the sumo ring is only 4 feet wide ang diameter, 'di ba? So
correct.
wala po 'yun sa distance na capacity ng sensor, it's on your code. Okay? Correct. So yung iba misconception is I would buy the higher cost because it's going to work better. That's another misconception, You don't have to, but of course, the quality, as per Ms. Maya, the quality of the legit parts are different. But in terms of range, you pick and choose which one suits your need. Kung kailangan mo mas malaking object, mas malayo na object to detect, then you pick a longer range of ultrasonic sensor. But if you are like what we said, you're going to use it for your sumo bot, there's a lot of coaches who may be watching. And some of the coaches naman are not really IT practitioners, no? They are coaches na voluntold. Okay, you were voluntold to coach and then you learn eventually. Ako voluntold.
Yes, correct.
Ako,
Marami pong ganun, Ma'am Jen.
Natuto
lang po sila through experiences nila.
Yeah.
Sa mga pag-attend ng mga webinars na tulad nito, ayan.
Yeah.
Yes.
Correct. So, yeah,
now,
be wise.
Yes, tama po yun. Now, Ma'am Jen, since I think wala na ata tayong katanungan, pwede na kaya tayo mag-proceed sa actual?
Yes, of course.
Yes.
You have
Naghanda
your,
din ako ng tubig dito at saka soil. I-demonstrate ko po yung sa inyo yung dalawang sensors natin dito. Ayan. So, ito po yung proof na pinaghahandaan nating mabuti yung ganitong klaseng webinar from Felta. So, we want an informative, webinar like this. Okay? So, Ma'am Jen, kung wala
Sir,
na tayong katanungan, I think we
yan.
can
Sige
proceed
lang.
with the actual demonstration.
Okay.
May I ask si Sir? Ayan. I think nakikita ko na yung aking
Yeah. I will
yeah.
hide also.
Yes, ma'am. So ngayon, ipapakita ko yung aking screen habang naka-flash po. Okay. Open ko po yung Arduino app ko. And ayan. So you can see here, narinig pa rin ako, no? You can see here po sa ating screen ang Sir Wax, pwede mo bang i-focus yung mismong, yan, ito, ating
Ayan.
actual Arduino to. Okay, kung
Ay,
wala po kayong
lapit
Arduino kit,
konti.
it's okay. Yan.
Lapit,
So,
lapit konti yung cam, Sir Dom. Medyo malayo. Zoom in sa saan? Nabababa mo pa ba yung mo,
I'm not sure
camera
po,
mo?
but I'm using my phone
Oh,
right
yeah.
now.
Maybe we can put it closer kasi medyo malayo.
Sige po, ma'am. Check
Yeah.
natin. Ayan. Minumove ko na siya. I'm not sure kung nakukuha po siya or, yeah.
Yan.
Resourceful. So I have my
Medyo
third
na.
camera here. So ito yung phone ko, gamit ko ngayon just to show you the actual Arduino. I'm using the Arduino Mega right now. And I have here you can see here in the camera, we have here the soil moisture sensor. And also we have here the actual water sensor. These two guys here are actually available also in the Arduino kit from Felta. So pwede niyong kunin. And also here we have the breadboard, the LED, the resistor, and also the Arduino Mega, which is actually connected to my computer already. Okay? The Arduino software is free. You can just download it. Pwede niyong search sa Google. So type niyo lang Arduino and lalabas na po yun. Now, first thing to do is to demonstrate how this sensor, this water sensor here, kung paano nga ba siya gumagana. Okay? So, you can see here na meron siyang tatlong wires, no? Connections. Kailangan natin i-connect. So, we have the S, we have the positive here, and we have the negative. Okay? I think I can show my screen right now. Just go to circuito.io. Okay. Sir Wax, can you show my screen, my computer? Habang naka-show din po yung ating tawag doon. Ayan. Para lang sa ganun, makita nyo po yung actual na itsura ng ating water sensor. Ayan. Ayan. So, thank you, Sir Wax. Eto guys, eto yung mismong design natin, no? You can see naman, ayan, ito yung distance sensor, sorry. Ito yung ating water sensor. It has 3 wires connected to our Arduino. It's the same, I'm just using Arduino Mega, but then it's the same code, the same schematic diagram, okay? So I'm using circuito.io. It's free. No need to purchase it. You don't need to sign up. Libre po ito, no? Now, you can see here the water sensor na nakakonect na sa ating Arduino Uno. We have the 5 volts connected to the positive. We have the GND, which is connected to our negative. And we also have the S, which is the signal connected to our A3 or analog 3. Okay? So, gayahin nyo lang po itong design na to, itong schematic diagram. Since you don't have this Arduino thing in your right now, then siguro screenshot nyo lang to later on para ganun. Kapag meron na kayo, sundan nyo na lang po. Okay? So, ang code po is this. Okay? Gagawa lang po ako ng panibagong code. Here, create nyo lang po ako. Okay? Of course, we need the void setup here. Okay? And opening curly bracket, we also need the void loop. Sorry. And then opening and closing curly bracket here. Under void setup, I need to type serial.begin. Ang gusto kong mangyari is to display the value of this sensor. Kapag nilagay ko siya, of course, kompleto tayo, may tubig tayo dito. Kapag nilagay natin yung ating sensor sa tubig, magbabago yung value. So that's why kailangan ko yung 9,600 dito. which is the baud rate. Under void loop, kailangan kong i-declare ang serial dot print ln and then followed by analog read. A, kung saan natin ilalagay mamaya yung ating mismong sensor, yung signal natin. So A, sabihin natin A0. Okay? And then of course, we need the delay. Delay 1,000 natin. Or around 500 milliseconds para medyo mabilis po yung response rate. Okay? Ayan. So, mas maganda nakikita yung aking screen. And at the same time, nakikita nyo po yung mismong actual na demonstration natin. Mas importante yung code, actually. Yeah. So, ngayon, since meron na tayong code, ililipat ko na lang ito mamaya sa mismong Arduino app. But I'll show you how to wire our this one, water sensor. So, I need 3 wires. We have here the male to female wires. Okay, so tatlong kailangan natin. Remember our circuit, schematic diagram. Connect po natin to. Okay, again, the negative wire, ito po, the negative wire should be connected to our negative breadboard. So, a negative, sorry, not breadboard, pin in our Arduino Mega. So, hanapin po natin yung negative. And let's connect this thing here sa ating GND. Ayan. Of course, we have also the positive, which should be connected to the positive also, 5 volts. Lagay natin siya sa 5V. Making sure it's correct. Ayan, it's plugged properly. Don't worry, hindi naman to hindi naman kayo ma-electrocute. And also the last one, we have also here the S or the signal, which should be connected to A0 because you can see in our code, we use A0 or analog 0. Ayan. So, complete na yung ating connections. All we need to do is to make sure to plug this thing to our USB port, no? Lagay na natin po siya. Yan. And of course, nag-light yung ating sensor. That means it's working. Okay? It's working. All right. Now, going back to our code, no? Since okay na yung ating design, yung ating circuit, copy na natin yung ating code, ilipat na natin sa ating Arduino. Ito na po siya. Ayan po. Let me just show you my screen again. Lakihan lang po natin para kitang-kita ng marami. Ayan. Sir Rox, can you show my my screen? Check lang po natin dito. If nakikita ko yung screen ko. Just to make sure. Okay, eto na yun. Ayan. So guys, ito yung actual Arduino setup natin, no? We have the serial that begin 1600, serial that print and analog read A0. We forgot something here, the closing parentheses, and delay 500. Now, since our Arduino is connected to our computer already, then we change the tools natin. Kailangan natin i-make sure na ang board natin is an Arduino Mega. You can see, sobrang dami ng board. So, do not forget to change, So, Arduino Mega, since Mega ang gamit natin, kanina ang ginagamit natin is Uno, then should be Uno also. So, since Mega, select Mega, going back to tools, and then the port number should be COMP5 Arduino Mega or Mega 2560, since this is the name of our port. Okay? So, select lang po niyan. Okay? Then, of course, we need to upload the program. How to do that? How to upload? You simply press this upload icon here. On the upper left corner of my screen, you can see upload, yung icon na arrow facing your right. Upload, click natin yan. And then, it's up to you if you want to save. But for me, I want to save and name it as water sensor --code. And then, since na-save na po siya, then automatically, ma-upload din yung ating program. Kung walang error ang ating program, makikita niyo po sa inyong screen, it should be done uploading. And you can see here, the message, sketch uses 2,184 bytes, blah, 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 here, okay? And then there's a prompt, it should be, the message should be done uploading, which means we have successfully uploaded our program. Now, the moment of truth, we need to open our serial monitor. We are talking about the actual demonstration. So ito yung serial monitor natin. It's on my upper right corner of my screen. You can see here. yung parang search bar natin dito. I think sa screen ko, natatakpan siya ng Felta PAOER na logo. So, nandito lang po siya sa upper right. Ayun, thank you sir. Thank you for that very quick response sa ating ano. Ayan. So, serial monitor. Click lang po ninyo yan. May lalabas na prompt. You can see, ano bang output? It's 0, nag-1, nag-3. Ayan, ito po siya. Ayan. Guys, you can see now. Ayan. Nasaan po ba ang ating water sensor? Nasa tubig. That's why you can see yung value po, nag-i-increase po siya. Now, kapag tatanggalin po natin yung water sensor sa mismong tubig, you can see that the value will decrease also. Ayan po. That means to say basa or dry or wet lang po siya. So, pwede nyo gamitin to. Paano ina-apply to sa mismong smart cities? No? Sa smart city. Kapag tag-ulan, nadedetect siya na halimbawa, nasa loob ka ng bahay mo, may sampay ka, no? May sampay ka. Ngayon, pwede mong gamitan ng water sensor ng servo yung sampayan mo. Yung wire ng sampayan mo, pwedeng gumamit ng continuous servo, okay? Continuous servo. Para sa ganyang continuous servo mo, nakakonect yung mismong string. Tama ba? Ma'am, nandiyan ka pa ba?
Oo, nandito ako. Oo,
I hope nag-gets mo yung idea ko, no?
oo, gets na
Sampayan
gets
siya,
na.
tapos yung
Actually,
string niya, nakakonect sa mismong servo motor na 360 or
oo,
continuous servo. Ngayon, kapag
tama.
umulan, madedetect ng water sensor natin yung ulan. Kapag umulan, magiging mataas yung value ng ating water sensor. Ngayon, pagaganahin
Oo,
natin yung servo, paikutin natin yung servo, para sa ganun, hihilain niya ngayon yung sampay natin.
correct.
Tatago
Kaya
na sa
lang,
loob ng bahay. Di ba?
Sir Dom, ingatan mo, pag may sipit, di ka kaya naglalabay, kaya di mo
Pag may sipit,
sipit, hindi siya
ay,
papasok yung line.
ayun, kapag may sipit po,
Oo,
ganito lang po yung idea niya. Kapag may sipit naman, kailangan merong allowance yung ating
correct.
cable, yung wire, di ba?
Oo, tama.
So,
Dapat may dadaan.
may
May engineering talaga yung
oo,
laba.
hindi
Huwag
lang
mo
to
nga i-remind
programming.
na maglalaba ako bukas, pero okay. So, yeah, there is
Pwede ka
very
ng pwede kang
interesting.
mag-mall.
Correct.
Without hindi ka na
Without compromising
tataranta na
your
umuwi. Yan,
laundry.
kasi
Mm-mm.
automated na. Autonomous na
Okay.
lahat. Di ba? Ayan,
Hindi
so,
nila masyadong kita yung i-twist mo, sir, yung para makita nila yung dip sa water. Now,
ayan,
if you pull out the water level sensor, meron yung mga, ang tawag dyan? Ah, lines. Nandun sa niya. Pakita mo, sir.
ayan
Bunot.
po. Ayan, so hindi mo na kailangan
nakadip siya.
mag-worry. Hindi mo na kailangan
Oo.
mag-worry kung, ay, may sampay ako, kailangan ko na umuwi. So, automatic
Ayan.
na yon, no? Gumagana yung
Yes.
servo mo. Di ba? Ayan, so pwede
Actually,
kayong gumawa ng
even
simple pattern.
practice. Mura lang yan. Mas
Yeah,
mura pa
actually.
kaysa compromise ang damit mo.
Yes. Kung wala kang dryer, di ba? Oh.
Correct. Okay. So,
Magugulat yung
yan.
kapitbahay mo, kusang lumililim yung mga sampay mo. Ayan po. So, simpleng idea lang.
Okay. Ano pa yung, may dalawa ka pang sensor doon, nakikita ko. Ayan.
Well, actually, this is isang
The
sensor
soil
na lang po ito,
moisture.
Jen. Ito ay soil moisture sensor. Ito kung gusto mong diligan ng halaman mo, ng automatic na pagdilig sa halaman. So, tanggalin ko na po itong tubig, baka matapon. Ayan. So, guys, huwag niyo pong gagayahin to sa computer kayo gumagawa. Baka matapon yung tubig. Okay? Ayan. So,
Bawal.
tanggalin ko na po ito. And then, iwawire ko na ngayon itong ating soil moisture sensor. So, Sir Wax, pwede mo po bang i-display ang aking screen? Ang aking screen po. Para maipakita ko po dito. Ayan. So, circuit.io. Remove lang natin to. And gagamit naman po ako ng mismong soil moisture sensor. Available din ang soil moisture sensor sa circuit to. Type lang po natin dito soil moisture. Para lang makita nyo yung itsura. And then add. And then automatic naman yung wiring po. Ito po siya, spark fan. Yan. Nga lang, syempre, knowing the name, spark fan, mahal po yan. Kung ako sa inyo local, ano na lang kayo. Or, of course, meron tayong cost-effective na sensor from Felta. Well, you can buy you can buy it also. Okay? So, ayan. So, same lang po sila ng nandito sa aking actual kit. But then this one is quite expensive. Okay? I'm using the not so branded. Cheap lang po siya. It's China made. Okay? So, yan. So, yan po yung gagamitin din natin. Same lang po siya. Now, going back to our code. Okay? Ito rin yung gagamitin natin para hindi na tayo matagalan. No?
Correct.
'Di ba? Ang galing ng Arduino.
Oo,
Same
you can
code
sit.
but different sensor.
Mm.
'Di ba? Isn't
Why
it
are they,
amazing?
ano pala, Sir Dom, we did not use Tinkercad here because the sensor is not available in Tinkercad.
Exactly
Yung
po.
ating ano, meron kayong masa-search, pero Paizo ang lumalabas.
Yeah,
Hindi
it's
po yun
Paizo.
yung actual. So,
Yeah.
yeah, you have to be, yun yung a disadvantage naman if you're using online resource. Yan po.
Yan. I think, Ma'am Jen, we can proceed with the ultrasonic sensor na.
Yep.
Yep. Now, so the same code, going back, the same code siya. Why the same code but different sensor? Ito po yung kagandahan ng Arduino. Ang Arduino, compatible yung code in different components. Isa pa pong, kapag meron kayong, ito hindi pa natin na ituturo, pero I'm very much willing to teach you, no? Ang Arduino pwede nating i-combine sa mismong EV3 or yung Mindstorm, yung Lego Mindstorm. Pwede natin pagsamahin po lahat yan. That's how flexible Arduino is. And Lego Mindstorm. Sobrang flexible niyan. Later on, kung meron tayong chance, ituturo din natin yan. But let's focus here muna. So same code, different servo, or different component. You can see here, meron tayo dito. The same. Ngayon, gagamitin natin yung analog 0. Ngayon, iwa-wire ko na to, Ma'am Jen. So, meron tayong component dito. Okay? So, i-connect ko lang po siya dito. Okay? Ayan. So, it doesn't matter kung saan po siya nakakonect. Wala naman pong positive or negative yan. Then, i-connect natin dito sa ating soil moisture sensor here. Ayan. Nakakonect na po yung dalawa. And of course, kailangan nating i-connect yung isa pa. Yung pinaka module natin, no? Meron niyang tatlo. Well, actually, 4. But then we're not using the digital pin. We're going to use the analog pin. So, hanapin po natin yung VCC. VCC, again, this is positive. We have also I think this is the same color. Eliminate muna natin yan because they're the same. And then we have also the G and D just beside the VCC, no? So, connect natin siya. Yan yung yellow natin is the GND. And then the other one, we have the analog A0 natin. Then connect it also. Ito yung orange natin. Then let's wire. Again, the VCC should be connected to the 5V. Yeah, that's connected to 5V. Making sure it's connected. And yung pangalawa yung yellow, this is GND. And then the last one, this is analog 0. Ayan. Now, to check whether our sensor is working, you can see the light. Once nag-light po siya, that's working already. Now, since meron na tayong program, excuse me, we don't need to upload it again. Hindi na natin kailangan mag-upload kasi na-upload na natin kanina yung program natin. All we need to do is going back to our program here in our Arduino. Ang gagawin ko po, i-open ko ulit ang serial monitor. Okay? Open ko ulit yung serial monitor natin sa ating Arduino application. Ayan po, anong lumalabas? 1023, 1023, 1023. Bakit po lumalabas ang 1023? Lumalabas po ang 1023 maybe because we have some problem sa ating connection or sa ating voltage. Check natin. Tama ba na GND? Tama ba na VCC? Tama ba na A0? I-double check po natin. A0 tama. Now, ito naman po yung ating sensor. You can see nagbago. Bakit siya nagbago? Kasi hinawakan ko. Merong resistance na. Kasi nakawakan ko na siya. Now, insert natin dito sa ating mahiwagang lupa. Okay? Ayan. So, shout out sa aking nanay na naghanap ng lupa kasi walang lupa po dito sa paligid. You can see yung value nagbago. Nabawasan po siya. Yan yung resistance na po. Now, kung meron something dyan, pwede nating palitan to, no? Baguhin ko lang konti yung ating arrangement ng wires. Meron kayang effect yung ating wire. Gaya ng sinabi ko kanina, pwede mo magbaliktad. Ayan po, the same pa rin po, no effect. Ayan. So now, bubuhusan ko ng tubig. Ibig sabihin nito, maybe somewhat dry yung ating tawag doon as sensor. Ayan. Okay, somewhat dry. Ayan. So lagyan natin ng tubig. Hindi naman po masisira kasi syempre soil moisture to. Ayan. Napansin niyo po bang bumaba ng bumaba? That means to say, medyo basa na po siya. Ayan. Ayan po. Bumaba po ng bumaba. Sir Wax, pwede mo bang ipakita yung ating screen? Yan. Ayan, bumaba po siya. Binuhusan ko po siya ng tubig, yung ating ayan. Yung resistance po niya. That means to say, basa yung ating soil. Kapag basa, syempre, hindi mo didiligan kasi basa na. Ngayon, remove natin. Ano kayang value? Ayan. Anong value? Tumaas. Ibig sabihin, dry. Dry na po yung ating soil moisture sensor. Ibig sabihin, it's time to what? To water the plants. 'Di ba? So, automatic sasabihin niya, basa, dry na yung halaman mo, baka malantayan. So, kailangan mong diligan. Okay, going back here. Ayan. So, saan ba makikita to? Again, sa smart cities, very familiar na to ngayon sa mga smart hydroponics, smart greenhouse. Yan, meron na po to ngayon. Gumagamit na sila ng
Ayan.
soil moisture sensor to water their plants. Okay? So, Ma'am
Okay.
Jen, I think na-demonstrate natin how to use this. Wala tayong
Correct.
ginamit food.
Oo.
Ayan, same food.
Speaking of ulan, uulan na. Kaya yan, we have 10 minutes left. Nandiyan ang tropa. Let's go. See
Yeah, we
them
have 10 minutes
again. 10 minutes.
Dito na tayo. 10 minutes. Ang galing ni Sir Dom. Virtual clap.
Oh.
Galing. Sinisip ko na.
Sinisip ko na, pagod na.
Kailangan sa labas.
Hindi sanay sa lupa.
Oo.
Hindi sanay ma-expose sa lupa. Ako puro lupa ako araw-araw.
Teka, meron tayong message dahil yung guest natin, naku, kawawa
Yes.
naman. Hindi daw talaga
Correct.
sila makapasok sa internet dahil, ewan ko Wisconsin, USA na po yung guest natin. But they made a video for us to welcome us. Connected naman po yung kanilang pinalabas na video with the Tinkercad that Sir Dom also demonstrated and Miss Jen, and also connected to the actual demonstrations na ginawa ni Sir Dom. So may we hear the message from Peter Haydock and Isabel Mendiola from Gearbox Lab USA.
Good morning. My name's Peter Haydock. I am the COO of Gearbox Labs, and our deepest apologies about the technical issues this morning. We've decided to record just a short hello video and share with you what we were going to say. I'm one of the co-authors of the Arduino Classroom, and really look forward to sharing our work that we've done over the last 6 years in this curriculum. And really my role this morning is to introduce Isabel Mendiola. She is our president and CEO of Gearbox Labs. She's also one of the co-authors, the other co-author really of the Arduino Classroom. It's her work in her classroom that the projects from the book came from. And so I'm very pleased to introduce her to you. I wish you all the best in your workshop today. And hopefully we will be able to connect live someday as well.
Good morning. Thank you for having us. So my name is Isabel Mendiola. I am the co-author of the Arduino Classroom curriculum. So I have a degree in pedagogy and master's degree in education. So I grew up in a industrial city with a need of workforce with skills in engineering is very important. So I had the opportunity to be teaching physics, chemistry, and biology, and it helped me a lot to cover part of this need. So I took my students to field trips, and one of the most interesting was the visit to the Association of Agriculture Engineers, where they explain how technology is being used in their jobs. So that is why part of this curriculum aims to environmental science and agriculture.
So again, thank you very much for joining us today. And again, we wish you all the best. And look forward to connecting with you soon. Thank you.
Thank you.
Bye-bye.
Ayan. I thought
Ayan.
our internet is bad. I am surprised.
Oo,
Sa
ganun
USA,
talaga.
sa USA ganun
Yeah,
rin pala. Parang ano,
actually, surprised ako dun.
ako surprised. Talagang super surprised. Okay, I think we have just 5 minutes left before we
Yes,
sign
ma'am.
off. Now, any words from Sir Dom? O sinipon ka na ng todo-todo?
Actually, sinisipon nag-e-enjoy ako ng sinisipon kanina, ma'am, while demonstrating. Well, I'm very much happy po sa ating mga viewers na marami pong nakasunod. Yung percentage kanina, sobrang thankful po kasi still kahit hindi maganda yung internet connection natin and we have a very limited time, you still able to follow. And thank you din sa Felta, kay Sir Wax and kay Ma'am Jen for having me here, and also our guests from Gearbox Love USA. We have an international guest which are very much willing to help us learn this type of topic which is Arduino programming. Again, thank you very much po sa lahat ng viewers natin. To end my demonstration, I would like to say that hindi po limited ang Arduino, not limited din ang Lego Mindstorm. We can also combine them together to create a more meaningful and more interactive or like more advanced technology. If we combine different technologies together, mas maganda po yung quality and mas maganda po yung output na magawa natin. Well, Falta can provide you all those stuffs, all those things naman, which is very much, yung quality niya is very, very good po. Ayan po. So, thank you very much po sa pag-invite po ulit sa akin, Ma'am Mylene, Ma'am Jen, and Sir Wax.
Meron
Huwag
pa tayo.
mag-alala, may next week pa. Okay.
Palakas ka na.
Oo.
go.
Papadalihan kita ng okra sa mga kinakalkal ko dito.
Okay.
Paglulupa.
So, Miss Jen, all right?
Yes,
Sir Wax,
ma'am.
any words for our viewers?
Thank
What
you
is
sa
Okay,
Hello.
sino ba?
Yan.
Okay, for
Ikaw
our,
muna.
I already posted the attendance evaluation and submission of output. So meron tayong output for today. So post na po siya, and then I'll be posting that also with Power INC page, Delta, and STEM5. Okay, so sa mga participants po namin, maraming salamat sa pakikinood sa amin para matuto. We learn as one. No, we continue to provide specialized training for you sa mga kagrupan mula po sa Pelta Multimedia. So maraming salamat, Ma'am Eileen, for giving us this special training para po sa ating mga kaguruan ng bansa. Okay?
Okay, yeah. Salamat po sa lahat na nag-participate sa Socrative. Alam ko, it's so hard to do multiple gadgets, but there's still people who try to do multiple. No? Alam ko nangangain ng load ang aming dalawang apps, but then you still manage to help us know if you are coping up with the stress and the fun and everything under the sun. Because this is very, very rewarding, especially if it's not just to be teachers, no? Those who are watching who have their own kids and might be inclined into engineering and STEM. If you see that your kids are inclined to those buting-ting na Arduino board, let's encourage them. We need them in the future. We're not always here. We need sustainable people, not just a sustainable development.
Okay. All right. Thank you so much. And then again, to our viewers, you will get your certificate of participation from Felta and Power. And we'll see you next week and the other weeks to come. More exciting learnings to come for us. Okay. So thank you so much and have a blessed weekend. Thank you.
Thank you. Bye-bye.
Bye.
Okay.